Let's see. Where am I at? Here we go. Yes.
Take a look at this photo. What is or are these struck by hazard or hazards in this photograph? Use your cursor to click the numbers that represent the possible hazards. The suspended load presents a falling and swinging struck by hazard to the workers. Also, it appears that the worker guiding the suspended load is not wearing hand protection.
No hand protection. Dang, dog.
Not a struck by hazard, but notice the debris on the ground, such as the 2x4 piece of lumber that presents a tripping hazard.
That's dangerous. Let's go to the next one. Yep.
The two employees on the right are not watching what could be a hazard approaching. In addition, there are at least two employees without high visibility apparel, which may make it difficult for the crane operator and other equipment operators to see them. Hard hats are one of the most recognized pieces of personal protective equipment found on a construction site. They are designed to protect your head from overhead hazards, falling and flying objects, and a host of other hazards on a construction site. Always keep your hard hat on. You have now completed the
Shut up.
rated for their intended use based on their ability to absorb shock and resist penetration. Always ensure that your hard hat is within its service life. The shell and lining of a hard hat should be replaced
Which is a fun.
according to manufacturer's recommendations. What are the results of being struck by falling objects? Select all that are correct.
Which is the following be considered flying hazard? A piece of material separate from tool. Yeah. All the above. Additional precautions such as using traffic signs. No, all the above. Yeah. The main cause of struck by. Yeah, all that. What can greatly increase the probability of a struck by vehicles that require the use of spotters? Blind corner and severe grade. Yep. Which of the following may be caused by a struck by incident? Serious bruises, all the above. To prevent equipment from being a hazard when not in use. Always do all that shit. To prevent a load from slipping, all those blah. Rig properly. Rapidly. Yeah, let's rig it properly, bro. Yeah.
We now will discuss a few of the most common causes of struck by swinging and slipping objects in an effort to help prevent them from happening to you. The most prevalent struck by swinging objects hazards are associated with lifting, moving, and rigging materials and equipment. Cranes and forklift operations occur daily on a construction site, and operator error, improper rigging, and or defective slings are a leading cause of workers being injured by a swinging or slipping load. When high-risk work, such as crane lifts and forklift operations, become a routine, it is up to each worker to ensure he or she doesn't become complacent by failing to follow safe working procedures. Simple things such as inspecting slings, using appropriate rigging, using a tag line on every load, and taking the time to do it right can prevent this type of hazard from becoming a life-changing event. Cranes, trucks, forklifts, boom trucks, and hoists all have the potential for a struck by or a slipping object incident. Look at the wire rope slings that are being used on the hook of this crane. What do you see that should be caused to remove these from service. Roll over the photo to find out. Yes, these wire rope slings. Did you
Yes.
happen to notice the custom-made safety catch that someone fabricated from a piece of rebar? This modification is illegal, but appeared to be an effective safety catch from a distance. Close examination shows that it in no way would prevent the sling loops from sliding off of the hook. Never mind. Click on the icon shown to view Fatal Facts Accident Summary number 51. If possible, print out this PDF worksheet and fill in the section Accident Prevention Recommendations with what you think may have prevented this accident. In this fatal fact, employees were dismantling grain spouts at a grain elevator. Sections of the spout were connected by collars. A 10-foot section of a spout weighing 600 pounds was being pulled through a vent hole by a 5-ton winch.
Really?
As the spout was being pulled through the opening to the outside, the spout became wedged at the point at which the collar was to pass through. Several employees used pry bars to free the collar, which was under tension. The spout popped out of the vent, striking and killing an employee who was standing beside the spout. The employer provided but did not require the use of hard hat. Now that you've come up with some ideas about accident prevention recommendations, let's review what OSHA's findings were.
Wow.
OSHA's inspection results. As a result of its investigation, OSHA issued 2 citations alleging serious violations. Employees should have been able to recognize that this situation was hazardous. Additionally, the investigation revealed that this employee was not wearing personal protective equipment in this hazardous situation. Had he been wearing a hard hat, this death might have been prevented. Accident prevention recommendations. Click on the OSHA compliance officers to learn what their recommendations were. Employees must be instructed in the recognition and avoidance of unsafe conditions and the regulations applicable to the work environment to control or eliminate any hazards or other exposure to illness or injury. 29 CFR 1926.21b2. Appropriate personal protective equipment must be worn by employees in all operations where there is exposure to hazardous conditions. 29 CFR 1926.26a.
Bubbles, dude, what? Oh, it's a party in here. Okay.
Now let's discuss struck by swinging object major hazards. When materials are mechanically lifted, they have the potential to swing and strike workers. As the load is lifted, the materials can swing, twist, or turn. This movement can catch workers by surprise, and they can be hit by the swinging load. Windy conditions are especially hazardous because the load will swing more. In another example, 2 workers were instructed by their foreman to set up a ground slab in the southeastern corner of a building. They were to land and place reinforcing steel
Okay.
using
Well,
a
it's
crane.
working.
A truck crane was positioned at street level, 30 feet higher in elevation than the ground slab, and about 162 feet from the landing area. The landing area was about 40 feet beyond the radius limit for the crane as specified by the manufacturer. The 24-piece bundle of 28.5-foot long number 9 rebar to be picked up and loaded onto the crane's line at street elevation 50 feet in front of the
Selling
crane.
mums up the road.
The operator made the pick and was swinging around and lowering it to a
Wife wants some
2 of the
mums,
most
purple and
common
orange,
struck by
but
flying objects hazards are
I haven't found
projectiles
any
created
yet.
by cutting,
So,
chopping, and
she
striking
found some.
materials and fasteners
Ooh.
such as nails, brads, and staples. Anytime you use a power tool to alter materials, whether wood, plastic, or metal, the potential for a dislodged piece of material to come loose and be thrown in any direction is very high. Using the correct tool, a sharp blade, and the correct procedures for the activity can help lessen the probability of having a projectile, but you always must use the proper personal protective equipment to protect yourself from injury. The use of powered nail guns also creates a high probability of creating projectiles, and it is crucial that you are properly trained in the inspection, use, and maintenance of electrical. Another example of a struck by flying object hazard includes the story of a worker who was removing a frozen bolt from the track of a Caterpillar front end loader.
Ooh, I can do that.
The bolt became unstuck as he was working on it, and it became a projectile that entered his forehead. The bolt was under load from the stress of the weight of the front end loader, and that energy suddenly released, causing the bolt to fly out and strike the worker. In a similar situation, A worker was spraying a pump component that was still under pressure. As the worker started taking the pump apart,
Alright,
he
let's
was
see. We can
impaled
do
by a
noir.
pump component. Both
Slate.
of these situations could have been prevented by first conducting a hazard analysis to evaluate both the obvious and hidden struck-by hazards, such as the residual energy that existed in both of these
We do
situations.
slate, dawn,
Always ensure a zero
crush.
energy state exists before starting work, or develop a work plan to complete the work safely.
Yep, safely. Got it.
A worker was killed when a sudden release of compressed air from a gas pipeline struck him. A compressor was started to fill the pipeline with compressed air in an effort to push out a pig. When the pipeline suddenly cleared, the employee was still in the way and was killed. The area should have been cleared before the compressor was started. Proper planning and safety precautions would have prevented the death of this worker. Take the time to plan each and every activity by conducting a hazard assessment and then developing a pre-task safety plan. Pre-task planning has been documented to improve both the safety and the productivity of those that use it effectively. Another example of struck-by fatality was a victim that was in the process of using an 8-foot stepladder to gain height to nail a strap onto a residential home single-story construction project. The victim used a nail gun with a 16-penny nail to affix the strap to the exterior wall. Using his right hand for the gun, he leaned over to the left and tried to place a nail into the strap. The nail ricocheted and struck him on the left side of his head just above the left ear. He fell to the ground and eventually passed out. Fellow workers transported him to the hospital. He died about 2 days later. Powder-actuated tools are particularly hazardous due to the force behind the fastener. These fasteners are designed to go through wood, concrete, and steel, and they certainly can go through workers. The use of powder-actuated tools requires specialized training, testing, and certification on each tool because they are very dangerous when used improperly. Using compressed air also can cause flying object hazards. Compressed air is commonly used to power tools and lifting devices. Always ensure that proper personal protective equipment is worn and that all pneumatic and powder-actuated tools are inspected before each use. Take a moment to click on the link and review OSHA's Hazard Alert, Nail Guns, Hand Out Appendix D. Workers should wear personal protective equipment or PPE. Safety glasses or goggles should be worn anytime work operations present an eye hazard. For example, during welding, cutting, grinding, nailing, or when working with concrete and/or harmful chemicals, or when exposed to flying particles. Click on the link to the handout Personal Protective Equipment. Take a look at this photo. Do you recognize any hazard or hazards?
Yeah, number one, he's gonna shoot that
Did you
dude.
recognize the...
It's not good.
Let's talk about some site conditions. Have you seen powder-actuated tools being used on site?
I have.
What are the hazards associated with these tools? Are special training and certifications required? Who is most at risk from the use of these tools? What precautions must be taken to ensure they are used safely? Click on each question to display the answer. As dangerous as a firearm. Flying particles of dirt, debris, scale, or particles discharged from the surface where the stud enters. Too heavy of a charge for the material, causing the stud to exit the other side. Ricocheting studs because of improper tool use or material that is too hard. Yes, only employees who have been trained in the operation of the particular tool shall be allowed to operate a powder-actuated tool. Everyone working with or around these tools. Many powder-actuated tool operators, as well as innocent bystanders, have died because of improper use of these tools. Always ensure that you are properly trained and have a full understanding of the safety and operational requirements for... Let's try again. Look closely at the worker in this photograph. What hazard do you recognize in the photo? You easily Let's talk about employer responsibilities. Employers must pay for PPE as required by OSHA. Provide and require the use of appropriate PPE in all operations where there is an exposure to hazardous conditions, and ensure adequacy of PPE, including proper maintenance and sanitation. Click on the safety tip and open the document. Employers must provide and pay for PPE. Training is a key component in any safety and health program. OSHA's minimum requirements are that employers must train workers in the work zone to recognize hazards associated with the use of the equipment and any related duties that they are assigned to perform. Ensure crane operators are qualified or certified according to OSHA standards, and ensure signal persons meet qualification requirements according to OSHA standards. Additionally, employers must instruct workers in the recognition and avoidance of unsafe conditions and the regulations applicable to his or her work environment to control or eliminate any hazards or other exposures to illness or injury, and ensure that all employees are trained for the hazards associated with the job classifications
My wife just sent me
and scope,
this.
and their specialized trades, such as equipment operators and riggers, are trained in the proper methods for their respective trade. During this lesson, you have been given an overview of common struck by hazards, ways to protect yourself and others on a job site from struck by hazards, and what employers must do to protect workers from struck by hazards. Should you have any questions, contact your supervisor, safety coordinator, or employer. Thank you for your time, attention, and involvement in the session, and please use
Okay, so my wife sent me this. She said, "Our life right now. Everyone has practice, so we can have dinner at 4:30 or 9 o'clock." Very true. Let's see. One who is capable of competent person. All right, here we go.
Welcome to this training course on personal protective and life-saving equipment. Given current OSHA and industry information regarding construction site illnesses, injuries, and fatalities, the objective of this course is to provide training information so the student will be able to determine, select, and use proper PPE and life-saving equipment in construction. Specific educational objectives will include types of hazards that require PPE and life-saving equipment, information to help the student identify and select appropriate PPE and life-saving equipment, information so that the student can protect him or herself from safety and health hazards, identification of employer requirements to protect workers from exposure to hazards. Additionally, this course will cover the various types of common personal protective equipment, or PPE, to include use, maintenance, inspection, and storage. The various types of PPE included in this course include head protection, eye and face protection, hand and arm protection, leg and foot protection, and whole body protection, to include the levels of protection against hazardous waste and hazardous substances as specified by OSHA and other agencies. We will also briefly discuss other types of PPE to include hearing protection, respirators, fall protection, and personal flotation devices. This course references applicable OSHA requirements specified in various sections of 29 CFR 1910 for general industry and 29 CFR 1926 for construction. Also, this course will reference other governmental and private organizations codified and referenced standards found in the American National
It looks
Standards
pretty neat. I
Institute,
mean, it's pretty
or
standard
ANSI,
stuff, but
and National
I
Institute
want that.
for
That looks pretty
Occupational
neat.
Safety and Health,
We need to go to
NIOSH, and others.
elementary in where TMMY lives. Not live, nothing to that, but
What? Okay, why?
where our daughter used to go to school,
Yes. Why?
they put in a brand new playground, and it is open to the public, and
As
it's
noted
huge,
earlier,
and it's
personal
amazing.
protective
What
equipment
multiple
is
parents
often
have told
simply
me.
It's open to
referred
public,
as
right?
Yes.
PPE.
Interesting.
Personal
So,
protective
Yeah,
equipment
we'll
includes
go
all
to
clothing,
we'll go to check
wearable
it out.
equipment, and
Yeah,
other
that'd be
work
cool.
accessories designed to create a
Yeah.
I
barrier,
saw where you dropped kids off there that
for
have it all
safety
tore
and
up
health
right now.
against workplace
yeah.
hazards.
Oh,
Just some asphalt or whatever they're redoing part of it.
yeah.
Personal protective
You
equipment
learn
is
about
often
personal
referred
protective
to
equipment?
as the third line of defense,
No, because
or
I've
the
done this
last line
before,
of
but not the
defense.
same kind.
It should not be used as a substitute for engineering
Yeah.
controls, which are considered
Walmart
the
has the
first
same
or
shit too.
primary
Anyway.
line of
Pretty much everybody
defense.
does.
Yeah.
For work practice and or
PPE.
administrative controls, the second line of defense.
Also PEs for like poop and
Personal
stuff.
protective equipment should be
No,
used
this is
in
for, like,
conjunction with or
hard hats.
support engineering or
Okay.
work
And
practice
glasses.
controls to
I love you.
provide for
What about
voice
you? Hey,
safety
you don't have
and
anything
health
in
in the
your pocket, do you?
workplace.
This little one I'm trying to finish.
Next.
Personal protective equipment is often
Next.
used in conjunction with engineering controls. As noted earlier, engineering controls are considered the first line of defense against workplace hazards. Engineering controls
Yeah,
include
so
hazard
you got-
substitution, hazard enclosures, hazard isolation, barriers, ventilation, and similar controls.
Love you too. You know where I'll be if you need me.
Okay.
Right here.
Work practice or administrative controls are considered the second line of defense after engineering controls. Work practice controls may include improved work procedures and housekeeping to minimize the need for PPE in the first place. And in conjunction with administrative controls, such as worker training, altering the work shift, or rotating workers frequently to minimize the total exposure to a hazard, such as noise, can be effective tools to minimize the need for PPE. Using PPE requires hazard awareness and training on the part of the user. Employees must be aware that the PPE does not eliminate the hazard. If the equipment fails, exposure will occur.
Great.
To reduce the possibility of failure, PPE must be properly fitted and maintained in a clean and serviceable condition. Selection of the proper personal protective equipment for a job is important. Employers and employees must understand the equipment's purpose and its limitations. It is common for the untrained to use PPE that is not intended to protect against a specific hazard. For example, employees have been known to have
Where's my
died in
switch?
oxygen-deficient atmospheres after having put on an air-purifying respirator thinking that they were protected. Air purifying respirators do not supply oxygen. They only filter the air.
What? The air, yeah.
PPE must not be altered or removed, even though an employee find it uncomfortable. PPE is manufactured with specific
See if this
parts and
works.
accessories, and the PPE
My Yoshi
manufacturers obtained approval
switch stand.
only after testing and meeting specific criteria. If parts and accessories are removed or altered, the equipment approvals no longer exist, and the equipment may actually become hazardous to use. Follow carefully the manufacturer's instructions for use. Sometimes PPE may be uncomfortable simply because it does not fit properly.
Oh, I got a mess going now, boy.
This training module focuses on those types of personal protective equipment most commonly used for the protection of the head, eyes and face, torso, arms, hands, and feet.
Yeah. Oh my god, it leans way back if I let it do its thing. Oh my god, there's so many cords now. Oh my goodness, what do I have going on? This setup is jacked, dude.
OSHA approves state workplace safety and health programs. Employers should check with the state OSHA program to determine what specific regulations apply. The individual state may be enforcing standards and other procedures that, while at least as effective as federal standards, are not always identical to the federal requirements. Click on the link to view OSHA's website, which identifies and provides additional information on state occupational safety and health plans. The first step in a PPE program is hazard assessment. It is critically important to assess the workplace to determine if hazards requiring the use of personal protective equipment are present or are likely to be present. If hazards or the likelihood of hazards are found, it is important to select and use properly fitted personal protective equipment suitable for protection from the hazards. See any hazards in the photo? Use your mouse to identify. OSHA requires that employers perform and document that a workplace hazard assessment has been performed to identify the hazards and necessary controls to include PPE that may be necessary to protect employees from hazards. What's wrong in this photo? Use your mouse to identify. Defective or damaged personal protective equipment must not be used. To prevent others from using damaged PPE, it should either be tagged as defective and repaired immediately
What if I do this?
or disposed of.
No. It's just gonna have to be like this. There it is. There we go. Except my mouse, whatever. Near.
Before doing work requiring the use of personal protective equipment, employees must be trained to know when personal protective equipment is necessary, what type is necessary, how it is to be worn, and what its limitations are, as well as knowing its proper care, maintenance, useful life, and disposal. In many cases, more than one type of personal protective equipment will provide adequate protection. In those instances, employees should be given a choice. History has shown that when employees are given a choice, PPE use most likely will be improved and the need for enforcement minimized. Federal OSHA requires that employers document, certify in writing that training has been carried out and that employees understand it. Each written certification shall contain the name of each employee trained, the date of training, and identify the subject matter covered, such as hard hats. Commonly used PPE and the conditions under which it will be used will be discussed as we move through this module. The PPE we will initially discuss includes head protection, eye and face protection, emergency eye wash and body protection, arm and hand protection, and foot and leg protection. In addition to the common PPE previously mentioned, there are conditions under which specialized PPE is warranted and is often used. These PPE include hearing protection, respiratory protection, body protection, levels of protection, fall protection, high visibility clothing, and personal flotation devices. All of these are delivered separately. Let's get started on head protection. A survey of accidents and injuries by the Bureau of Labor Statistics, BLS, noted that most workers who suffered impact injuries to the head were not wearing head protection. Head injuries are caused by falling or flying objects or by bumping the head against a fixed object. Head protection in the form of protective hats must do two things: resist penetration and absorb the shock of the blow. Head protection is accomplished by making the shell of the hat of a material hard enough to resist the blow and by utilizing a shock-absorbing lining composed of headband and crown straps to keep the shell away from the wearer's skull. Protective hats are also used to protect against electric shock. OSHA requires in their construction standard that employees exposed to flying or falling objects and/or electric shock and burns shall be safeguarded by means of approved head protection. The standards recognized by the OSHA Construction Standards for Protective Hats are contained in American National Standards Institute ANSI Z89.1.
Really? Okay.
Type 1, head protection designed to protect from objects that fall from above. Type 2 offers lateral impact protection plus hazards that fall from above. Helmet types 1 and 2 are now subdivided into classes E, G, and C.
Ooh.
Class E is intended to reduce danger of exposure to high voltage electrical conductors, proof tested to 20,000 volts. Class G is intended to reduce the danger of exposure to low voltage electrical conductors, proof tested at 2200 volts. Class C hard hats are not tested for electrical resistance. They are acceptable for impact and penetration of falling and flying objects.
Oh yeah.
They are not intended to provide the...
Yeah.
Use your mouse to identify what's missing in the photo. Each type and class of head protection is intended to provide protection against specific hazardous conditions. An understanding of these conditions will help in selecting the right hat for the particular situation. The wearer of protective helmets should be able to identify the type of helmet by looking inside the shell for the manufacturer, ANSI designation, and class. The internal cradle of the headband and sweatband forms the suspension. Headbands are adjustable in 1/8 size increments. When the headband is adjusted to the right size, it provides sufficient clearance between the shell and the headband. Manufacturers should be consulted with regard to paint or cleaning materials for their helmets because some paints and cleaning materials, such as thinners, may damage the shell and reduce protection by physically weakening it or negating electrical resistance. A common method of cleaning shells is dipping them in hot water, approximately 140 degrees Fahrenheit, containing a good detergent for at least a minute. Shells should then be scrubbed and rinsed in clear, warm water. After rinsing, the shell should be carefully inspected for any signs of damage. What's going on in the photo? Use your mouse to find out. All components, the shell, suspension, headband, sweatband, and any accessories, should be visually inspected daily for signs of dents. Helmets should not be stored or carried on the rear window shelf of an automobile, since sunlight and extreme heat may adversely affect the degree of protection. Helmets should be...
True.
Let's review the importance of head protection by reviewing a real-life workplace accident and the lessons learned. 2 employees were involved in a metal fence installation project around a community landfill. Equipment used was a handheld fence post slide hammer and metal fence posts. An accident happened when one employee, kneeling on the ground holding steady the metal fence post, was struck on top of the head with the slide hammer. Second employee, standing,
God, that sounds
raised the slide
terrible.
hammer above the top of the fence post, drove down the hammer, missing the fence post and striking the ground employee on the top of his unprotected head. Emergency services were called in on a cell phone. The seriously injured
On a cell
employee
phone.
required surgery and was temporarily paralyzed from the event. He could have easily died as a result of the blow to his unprotected head. This injury would have best been prevented by using engineering controls or work practice controls. However, the severity of injury would have been reduced by the use of an appropriate protective hard hat.
A typical foot injury is caused by objects falling fewer than 4 feet with a median weight of about 65. Sure, yeah, I'll believe that. Oh, sure.
Now let's talk about eye and face protection, starting with the eyes. Statistics for eye injuries are staggering. Thousands of people are blinded each year from work-related eye injuries that could have been prevented with the proper selection and use of eye and face protection. The financial cost of these injuries is enormous. Hundreds of millions of dollars per year in lost production time, medical expenses, and workers' compensation. Of course, no dollar figure can adequately reflect the personal toll these accidents have on injured workers and their families. What contributes to eye injuries at work? In general, not wearing eye protection at the time of an incident results in most eye injuries. Wearing the wrong kind of eye protection is also a significant factor. What causes eye injuries? Flying particles are typically the number one cause of eye injuries, followed by contact with chemicals, then other factors and objects including injurious light rays from welding arcs, lasers, and other sources. Although most eye injuries do not result in permanent damage, they are almost always painful, and there is always a potential for loss of sight in one or both eyes. Fortunately, with proper selection and use of personal protective equipment, most eye injuries can be prevented. How can eye injuries be prevented? Always wear effective eye protection. To be effective, eyewear must be appropriate for the hazard encountered and be properly fitted. Better training and education. Even though the vast majority of employers furnish eye protection at no cost to employees, about 40% of the workers receive no information on where and what kind of eyewear should be used. Maintenance. Eye protection devices must be properly maintained. What do you see in the photo? Use your mouse to identify. Eye and face protection and protective devices are generally categorized into 4 different classifications. They are safety or protective glasses, goggles, face protection,
stupid bag.
and welding shields. What do you think about the setup in the photo? Use your mouse for our interpretation. Safety glasses. Safety spectacles are protective
Jeez,
eyeglasses
that
made
went
with safety
crazy.
frames, tempered glass or plastic lenses, temples, and sight shields, which provide eye protection from moderate impact and particles encountered in job tasks such as carpentry, woodworking, grinding, scaling, and similar work. Safety glasses are also available in prescription form for those persons who need corrective lenses. Can you spot any hazards in the photo? Use your mouse to identify.
To identify.
Goggles. Vinyl framed goggles of soft, pliable body design provide adequate eye protection from many hazards. These goggles are available with clear or tinted lenses, perforated, port-vented, or non-vented frames. Single lens goggles provide similar protection to spectacles and may be worn in combination with spectacles or corrective lenses to ensure protection along with proper vision. Face shields normally consist of an adjustable headgear and face shield of tinted or transparent acetate or polycarbonate materials, or wire screen. Face shields are available in various sizes, tensile strength, impact or heat resistance, and light ray filtering capacity. Face shields are used in operations when the entire face needs protection and should be worn to protect eyes and face against flying particles, metal sparks, and chemical or biological splashes. What's going on in this photo? Use your mouse to find out.
He's one of those people that needs to be watched out for. He's an extreme nipple shower. Can't have that. All right, public service announcement. We have a man here on TikTok that needs to be called out. He's a TikTok runner. Doesn't even stretch. So can you really be called runner at that point there? But he's got a baby beard, doesn't even have a full beard. It's not like a lion's mane or anything like that. But he's one of those people that needs to be watched out for.
Welder's goggles provide protection from sparking, scaling, or splashing metals and harmful light rays. Lenses are impact resistant and are available in graduated shades of filtration.
We have a man here on TikTok that needs to be called out. He's a TikTok runner. Doesn't even stretch. So can you really be called runner at that point there? But he's
Welding shields protect eyes and face from infrared or radiant light burns, flying sparks, metal spatter, and slag chips encountered during welding, brazing, soldering, resistance welding, bare or shielded electric arc welding, and oxyacetylene welding and cutting operations. Filter lenses have a shade number appropriate for the work being performed for protection. Shade numbers range from 1 through 14. For example, typical gas welding requires a filter shade of 8. To prevent injuries from injurious light radiation, each affected employee should use equipment with filter lenses that have a shade number appropriate for the work being performed for protection. Shade numbers range from 1 through 14. For example, typical gas welding operations require a filter shade of 8. Eye and face protectors must meet minimum requirements. They must provide adequate protection against the particular hazards for which they are designed. Be reasonably comfortable when worn under the designated conditions. Fit snugly without interfering with the movements or vision of the wearer. Be durable. Be capable of being disinfected. Be easily cleanable and be kept clean and in good repair. Many hard hats and non-rigid helmets are designed with face and eye protective equipment. This combination equipment increases the effective use and minimizes equipment getting lost or misplaced. Design, construction, testing, and use of eye and face protection must be in accordance with ANSI Z87.1, the American National Standard Practice for Occupational and Educational Eye and Face Protection. In addition, eye and face PPE must be distinctly marked to facilitate identification of the manufacturer. Fitting of goggles and safety spectacles should be done by someone skilled in the procedure. Prescription safety spectacles should be fitted only by qualified optical personnel. It is essential that the lenses of eye protectors be kept clean. Daily inspection and cleaning of the eye protector with soap and hot water or with a cleaning solution and tissue is recommended. Dry the lenses and frames following the manufacturer's recommended procedures. Safety glasses and goggles should be kept in a case or otherwise protected when not in use. Replace the eye protector when lenses are found to be pitted and deeply scratched, and when slack, worn-out, sweat-soaked, or twisted headbands of goggles are found. Eye protection should be replaced with the make and model for which you were initially fitted. Eye and face protection that has been previously used should be disinfected before being issued to another person. Also, when each employee is assigned protective equipment for extended periods, it is recommended that such equipment be cleaned and disinfected regularly. Clean and disinfect following the manufacturer's instructions. Generally, cleaning and disinfecting is performed with soap and warm water or in a solution of germicidal deodorant fungicide, allowed to air dry in a clean area, then placed in a clean, dust-proof container, such as a box, bag, or plastic envelope to protect them. Eye and face protection, like other PPE, is used for very important reasons. Let's take a look at a real event, a lesson learned. As a result of one company's safety glasses program, an employee encouraged his 18-year-old son to wear safety glasses while working at his construction job. His son was resistant and felt he didn't need them, even though he had gotten aluminum dust in his eyes while cutting gutter material earlier. The employee continued to encourage him to wear the safety glasses, and his son finally relented and started wearing them. Following the incident, the dad said, "The safety glasses definitely saved his eyesight and possibly his life. If only one eye is saved, the program is worthwhile, especially if it is your or your son's eye." Make safety a culture, a way of thinking, a way of acting that reaches beyond our workplace into our everyday lives and the lives of others.
What's up?
My office tote still in here?
I don't know.
Oh yeah, it's right here. My push pins, they're in there.
Oh, I would have got them. You could have something down. Which is fine.
Maybe I don't know.
It's not that big a deal. It's fine.
Oh, sorry.
Which is fine. It's not.
OSHA requires that where the eyes or body of any person be exposed to injurious corrosive materials, suitable facilities for quick drenching or flushing of the eyes and body shall be provided within the work area for immediate emergency
For
use.
now. Not like I don't have to repair these walls anyways.
Emergency eye wash or shower facilities meeting the requirements of ANSI Z358.1 must be provided in all areas where the eyes of any employee may be exposed to corrosive materials. All such emergency facilities, whether fixed or portable, should be located where they are easily accessible in an emergency. The eye wash and shower station is an essential tool to accomplish the recommended decontamination. ANSI Z358.1 requires locating emergency eye wash and shower stations in an area reachable within 10 seconds following an exposure event. The emergency equipment also must be installed on the same level as the posing hazard with a travel path free from obstructions. The quantity of water should be enough to flush exposed surfaces of the body for a period of at least 15 minutes, and the water temperature be tepid. Generally, supply water temperatures should be in the 78 to 92 degree Fahrenheit range. The shower or eye wash must have an on or off control valve that stays open once actuated until intentionally or manually turned off. And in cases where the temperature of the installed shower can drop below 32 degrees Fahrenheit, freeze protection is required. Test the eye wash and shower stations monthly to ensure their functionality with extensive evaluation conducted on an annual basis to ensure compliance with the flow and water distribution requirements outlined in ANSI Z358.1. Employees who are at risk of exposure to the hazardous chemicals require training in the proper use of eye wash and shower stations. Arm and hand protection. Examples of injuries to arms and hands are burns, cuts, electrical shock, amputation, and absorption of chemicals. There is a wide assortment of gloves, hand pads, sleeves, and wristlets for protection against various hazardous situations. It is important to determine what hand protection is needed. The work activity should be studied to determine the degree of dexterity required, the duration, frequency, and degree of exposure to hazards, and the physical stresses that will be applied. Also, it is important to know the performance characteristics of gloves relative to the specific hazard anticipated. For example, exposure to chemicals, heat, or flames. Talk to the manufacturer, vendor, supplier, or company safety and health coordinator regarding the performance characteristics of hand and arm protection. What do you see in the photo? Use your mouse to verify.
To verify. What do I see? I see a Dude.
Use the right protective equipment correctly. This lesson learned illustrates a fatality from using the wrong hand protection. What's going on in this photo? Use your mouse to find out.
What is going on? What a bullshit.
In a recent accident at an American college, a chemist died as a result of acute exposure of dimethylmercury. This unfortunate incident underscores the importance of correctly selecting and using personal protective equipment. In this particular exposure, the chemist was doing research on the biological toxicity of heavy metals. Records indicate that she handled dimethylmercury on only one day while wearing latex gloves and working under a ventilated hood designed to prevent exposure to chemical fumes. The person died just 298 days after exposure through the gloves to several drops of the mercury compound. Following the accident investigation, it was reported that since dimethylmercury is a super toxic chemical that can quickly permeate common latex gloves and form a toxic vapor after a spill, its synthesis, transportation,
Oh, it stopped. Oh no. Well. Jacking it all up.
and use
There
even
we
by
go.
scientists should be kept to a minimum, and it should be handled only with extreme caution and with the use of rigorous protective measures. Recommended action. When considering work with a highly toxic material, consult with an experienced industrial hygienist for guidance regarding the selection of protective clothing, including gloves. A note about safety data sheets or SDSs. SDSs can be a good source of information to identify the hazards and safe work practices for hazardous substances. However, they are often very generic and non-specific. For example, in this incident, the SDS for the dimethylmercury said, wear appropriate chemical-resistant gloves. For many toxic compounds, this statement is simply too vague to provide adequate guidance for glove selection. Before purchasing gloves, request documentation from the manufacturer that the gloves meet the appropriate test standards for the hazard anticipated. For example, for protection against chemical hazards, toxic properties of the chemical or chemicals must be determined, particularly the ability of the chemical to pass through the skin and cause systemic or whole body effects. The protective device should be selected to fit the job. For example, some chemical-resistant gloves are designed to protect against specific chemical hazards. Wire mesh, leather, and canvas provide protection from burns and cuts. Also, it is really important to become familiar with the limitations of the clothing used. Use your mouse to identify hazards in the photo. Certain occupations require special protection. For example, electricians need special protection from shocks and burns. Rubber is considered the best material for insulating gloves and sleeves from these hazards. Rubber protective equipment for electrical work must conform to the requirements established by ANSI. Welders and those performing similar hot work must wear appropriate PPE, such as face shields, leather gloves and gauntlets, leather aprons, and fire-resistant clothing, which are designed to prevent burns by protecting from welding slag, sparks, UV radiation, and radiant heat. Clothing must exhibit fire resistance consistent with OSHA standards and applicable portions of ANSI Z49.1. In this lesson learned, the incident could have been prevented by effective work practice and engineering controls. The injury or seriousness of the injury could have been prevented by correct PPE. Even routine maintenance actions that have been performed many times can occasionally lead to accidents or injuries. Appropriate personal protective clothing, procedural precautions, and engineered safeguards should be employed to guard against all reasonable accident scenarios. Two heavy-duty equipment mechanics were attempting to remove a gland nut from the end of a leaking hydraulic lift cylinder while performing routine corrective maintenance on a man lift. They could not remove the gland nut using only mechanical methods, so they applied heat with an oxyacetylene torch to release tension on the nut. Hydraulic fluid trapped between the leaking seal and the wiper seal vaporized, escaped from the leaking seal, and ignited from the heat of the torch. One employee received first and second degree burns on his right forearm from the vapor flash. Similar repairs had been performed safely without incident hundreds of times in the past. In this case, the workers wore appropriate personal protective equipment, PPE, for the job. However, the injured employee's coverall sleeve was raised to the elbow, exposing his bare forearm. Normal flexing of his arm apparently caused his sleeve to work up his arm while working. Full welders PPE was not prescribed since this was not welding. Recommended actions. Wear full hot work PPE, including fire retardant gloves with gauntlets and a face shield when heating components. Remove all potential fire hazards from the area before performing hot work. Conduct periodic refresher training on hot work techniques and safety practices. Include potential hazards identified in job hazard analysis for hot work. Foot and leg protection. According to the BLS survey, most of the workers in selected occupations who suffered foot injuries were not wearing protective footwear. Furthermore, most of their employers did not require them to wear safety shoes. The typical foot injury was caused by objects falling fewer than 4 feet, and the median weight was about 65 pounds as employees performed their normal job. For protection of feet and legs from falling or rolling objects, sharp objects, molten metal, hot surfaces, and wet, slippery surfaces, workers should use appropriate foot guards, safety shoes, or boots and leggings. Leggings protect the lower leg and feet from molten metal or welding sparks. Safety snaps permit their rapid removal. What do you see in the photo? Use your mouse to identify. Aluminum alloy, fiberglass, or galvanized steel foot guards can be worn over usual work shoes although they may present the possibility of catching on something and causing workers to see anything positive in this photo. Use your mouse to identify. There are many types of foot protection, for example, to protect against falling and rolling objects, cuts, and punctures. These include steel-toe safety shoes, add-on devices, metatarsal guards, metal foot guards, puncture-proof inserts, and shin guards are often worn. Good safety shoes should be sturdy and have an impact-resistant toe. In some shoes, metal insoles protect against puncture wounds. Safety shoes come in a variety of styles and materials, such as leather and rubber boots and Oxfords. Safety footwear is classified according to its ability to meet minimum requirements for both compression and impact tests. 29 CFR 1926.96 and 1910.136 reference ANSI Z41. However, in 2005, ANSI Z41 was withdrawn and replaced by two new American Society of Testing Materials, ASTM, international standards. The new ASTM standards are F2412-05 standard test methods for foot protection and F2413- Other common foot hazards and protection include: for chemicals and solvents, impermeable protective footwear with synthetic stitching and made of rubber, vinyl, or plastic. It is critically important to know the specific chemical and solvent to which your feet or legs may be exposed. As with glove protection, many manufacturers of chemical-resistant footwear will have chemical-resistant guides that will identify which type of rubber, vinyl, plastic, or other synthetic foot protection will offer the greatest chemical resistance and protection. Can you find any PPE issues in the photo? Highlight with your mouse. Workers exposed to live electrical conductors must wear safety footwear. Soles of electrical resistance footwear have specific electrical insulating properties. Insulating properties of footwear will deteriorate in wet environments and with wear. Rubber or cork soles and heels, no metal parts, and insulated steel toes. Foot protection for extreme cold hazards includes shoes or boots with moisture or oil-resistant installation and that can repel water if water is a problem, and insulated socks. And foot protection for extreme heat and direct flame hazards include overshoes or boots of fire-resistant materials, often with wooden soles. For sanitation or biological contamination, use special plastic booties or overshoes, or paper or wood shower sandals. For slips and skids from wet, oily shoes and soles or cleated surfaces, use non-slip rubber or neoprene soles, non-skid sandals that slip over shoes, or strap-on cleats for icy surfaces. To eliminate sparking hazards from metal shoe parts, use safety shoes with no metal parts and non-sparking material. For sparking hazards from metal shoe parts, safety shoes with no metal parts and non-sparking material. For sparks, molten metal splashes, foundry boots with elastic sides or that get inside shoes, quick release buckles for speedy removal. For static electricity, protection, shoes or boots with heels and soles of cork or leather. Hazard, wetness, protection, lined rubber shoes or boots, or shoes of silicon-treated leather.
The
PPE is only a tool in the fight against workplace hazards. PPE is not the first line of defense. Engineering controls, ventilation, isolation, enclosures are the preferred method. Before acquiring PPE, it is important to do a hazard assessment followed by implementation of an effective program of PPE selection, use, maintenance, inspection, care, storage, and employee training. To learn more, click on the link to OSHA's Personal Protective Equipment. This is a continuation of the training session on PPE. Now we'll explore some of the more specialized types of PPE. This module covers the various types of specialized personal protective equipment, PPE, to include its selection, use, maintenance, inspection, and storage. The various types of specialized PPE included in this module are hearing protection, respiratory protection, fall protection, high visibility apparel, and drowning protection. This training references applicable OSHA requirements for PPE and related agency and other organization standards. The estimated length of this module is 45 minutes. The audience is intended to include employees, supervisors, and managers who use, select, maintain, and inspect PPE. We'll be covering several types of specialized PPE commonly found in the workplace to protect against unique hazardous situations such as noise, airborne contaminants or oxygen deficiency, chemical exposure to the body, fall hazards, mobile equipment, and working near or over water. Also, this course will present in general terms specialized PPE, selection, use, maintenance, inspection, and care. And will present case studies to underline the need and use of specialized PPE. References for this course are OSHA requirements, various sections of 29 CFR 1910 for general industry and 29 CFR 1926 for construction, American National Standards Institute, ANSI, National Institute for Occupational Safety and Health, NIOSH, United States Coast Guard, and others. Noise or unwanted sound is one of the most common occupational health problems. Approximately 30 million people in the U.S. are occupationally exposed to hazardous noise. About 10 million people have occupational noise-induced hearing loss. Fortunately, the incidence of noise-induced hearing loss can be reduced or often eliminated through the successful application of engineering, work practice, and personal protective equipment programs. Employers must institute a hearing conservation program in the workplace if noise may be hazardous. To determine if a hearing conservation program is necessary or required, the employer must first measure the noise in the workplace. Measuring noise levels and noise exposures is the most important part of a workplace hearing conservation and noise control program. Noise monitoring helps identify work locations where there are noise problems, employees who may be affected, where additional noise measurements may be needed, and employees that may need hearing protection. OSHA requires employers to monitor noise exposure levels in a manner that will accurately identify employees who are exposed to noise at or above 85 decibels, or dB, averaged over 8 working hours, referred to as an 8-hour time-weighted average, or TWA. The exposure measurement must include all continuous, intermittent, and impulsive noise within an 80 to 130 decibel range and must be taken during a typical work situation. Monitoring should be repeated when changes in production, process, or controls increase noise exposure. Instruments used for general noise measurements and for monitoring employee exposures include acceptable types of sound level meters, octave band analyzers, or noise dosimeters. Noise monitoring instruments must be carefully checked and calibrated to ensure that the measurements are accurate. OSHA has developed a hierarchy of controls to control noise hazards. Engineering controls such as redesigning, changing, substituting equipment to remove or reduce the source, or the use of enclosures of noise-producing moving parts of machinery. Administrative controls and work practice controls, which include designing safe work practices into job procedures and maintaining equipment and tools in good repair, lengthened rest breaks, job rotation. Hearing protection is used when noise hazards cannot be otherwise controlled through engineering, administrative, or work practice controls. Use of hearing protection does not control the hazard, but protects by setting a barrier between the worker and the hazard. Use of hearing protection may also be appropriate for controlling hazards while engineering, administrative, and work practice controls are being implemented. Basically, the goal of hearing protection use is to minimize the frequency and intensity of the noise to the ear. People should wear a hearing protector if the noise or sound level at the workplace exceeds 85 decibels, A-weighted or dBA. When effective hearing protectors are worn properly, they can reduce the risk for damaging your hearing. What is a decibel? The decibel, or dB, is a unit of measurement of sound pressure level or sound level. Typical sound levels are: jet aircraft take off at 50 feet, 135. Threshold of pain, 130. Chainsaw, 110. Power mower, 95. Passing motorcycle, 90. Conversational speech, 60. Quiet bedroom at night, 25. As mentioned earlier, safety experts agree that to protect your hearing, you should wear ear protectors if your noise level exceeds 85 decibels. There are 4 basic types of hearing protectors. They are molded earplugs, custom molded earplugs, self-molded earplugs, and earmuffs. Molded earplugs are usually made of plastic or silicone rubber. They are available in a variety of shapes and sizes and are usually characterized by one or more ribs or contours. They are considered multiple use. Therefore, they must be cleaned and properly stored after each use. Custom molded plugs are generally made of plastic and are designed from a molded wax insert of the wearer's ears. They are considered multiple use but cannot be switched ear to ear. Multiple use earplugs need to be kept clean to prevent ear infection, and they do eventually wear out. Consult the manufacturer's requirements for cleaning and change out. Self-molded earplugs are generally made of mineral down or plastic foam and are molded or formed by the wearer. Generally, one size fits all, and they may be either single or multiple use. Self-molded earplugs are prepared for insertion by rolling them into a thin, crease-free cylinder, inserting into the ear canal and holding in place with a fingertip for a few moments until the plug begins to expand and block the noise. Roll into a thin cylinder, insert into ear canal, hold in place with fingertip, plug will expand. To avoid contamination and possible ear infections when inserting earplug devices, follow these simple but effective guidelines. Wash hands before inserting earplugs. Replace disposable earplugs after each use. Clean reusable earplugs after each use. Earmuffs are designed to multiple use and may be designed to be worn with a harness over or behind the head or below the chin. They are generally more comfortable, but usually provide less noise reduction, thus less protection than custom molded earplugs. The discussion of respiratory protection can be very broad, and to meet OSHA's training requirements, you will need additional training if you are required to wear one for your job. The subject of respiratory protection is discussed in greater detail in other training modules on respiratory protection. Respirators are often used in the workplace or on the job site to protect against airborne contaminants and oxygen-deficient atmosphere. The use of respiratory protection on the job starts with an effective program. First of all, respirators used in the workplace must be approved by the National Institute for Occupational Safety and Health, also known as NIOSH. The elements of an effective respiratory protection program include respirator selection, medical evaluation, fit testing, training, use, maintenance, inspection, and more. It is important to inspect respirators. Why? This lesson learned shows that proper inspection and fit checking before using a respirator in actual conditions can avoid an injury. A waste management operator was performing the pre-use inspection and negative pressure user seal check of a respirator when the exhalation flapper valve was sucked into the exhalation valve body. Investigation determined that during routine repair and checks by site personnel, the flapper valve had been replaced with one designed for use with a different respirator. Comparison of the valves found similarities in design and appearance. However, the replacement valve was marked differently and was thinner in construction. No exposure or injury occurred in this event. However, use in actual conditions before fit testing could have resulted in serious injury. Recommended actions. Inspect all respirators on site and remove from service those respirators with incorrect flapper valves. Brief all personnel of the problem and instruct them not to replace any flapper valves until the correct part has been obtained and the procedure is revised. The basic classes of respirators include the air purifying devices, which do not have a separate air source. They purify through filtering. Atmosphere supplying respirators, which supply air from an air supply either carried by the user or located some distance connected by an airline hose. Air purifying devices cleanse the contaminated atmosphere as ambient air passes through an air purifying element to remove specific gases and vapors, aerosols, or a combination. The air purifying respirator is lighter and has advantages over the air supplied respirator by enhancing the wearer's mobility. They cannot be used in immediately dangerous to life or health environments or oxygen deficient atmospheres. They have limited duration of protection and protect against specific chemicals and up to specific concentrations. Air purifying devices have limited use to those environments where there is sufficient oxygen to support life, more than 19.5% oxygen, and the air contaminant level is within the use concentrations of the devices. Generally, they are limited to air contaminants that are not highly toxic or the airborne contaminant levels are low. Air purifying respirators must not be used if air contaminants or their relative concentrations are unknown. Air purifying respirators selectively remove specific airborne contaminants from ambient air by filtration, absorption, adsorption, or chemical reactions. And there are two principal types of air purifying devices: the aerosol or particulate removing respirators, sometimes called dust or mist respirators, and the gas or vapor removing respirators. Let's visit a real incident and identify a lesson learned. In this incident, a 32-year-old environmental technician was seriously injured when the respirator that he was wearing was ineffective against a caustic vapor to which the employee was exposed. The employee received burns to the throat and larynx, causing permanent scarring. The injured employee had been collecting samples of possibly contaminated liquid from an unlabeled container. Information indicated the liquid was probably contaminated with low-level organic petroleum hydrocarbons. An NSDS was not immediately available. The employee selected a full-face air purifying respirator with organic vapor cartridges, as was standard practice at the facility. As the employee collected the sample, he experienced a burning in the throat. The employee immediately left the area and removed the respirator. Attempting to tell coworkers what the problem was, he found that he could not voice words. The employee was rushed to the emergency care unit of the local hospital. The diagnosis was acute chemical burns to the upper respiratory tract. The injury resulted in permanent scarring of the upper respiratory tract. The employee will have difficulty talking for many years to come. The accident investigation revealed that there was more in the liquid than low-level organic petroleum hydrocarbons. It also contained a caustic ammonia product that somehow got into the liquid for which the cartridges in the air purifying respirator were ineffective. The caustic vapor easily passed through the organic vapor cartridge, entering the employee's upper respiratory tract, causing the serious chemical burn. The lessons learned from this incident. Another type of air purifying respirator is the powered air purifying respirator, also known as the PAPR. Equipped with a filter, chemical cartridge, or canister similar to the aerosol removing respirators and the gas or vapor removing respirators, the PAPR differs by using a power source to operate a blower that passes air across the air cleansing element to supply cleansed air to the user. The second major type of respirator is the atmosphere supplying respirator. This type of respirator supplies breathing atmosphere to the user from an uncontaminated source, from a compressor through a hose line or compressed air cylinder, a self-contained breathing apparatus. The breathing air must meet strict air quality standards, and a copy of the breathing air quality certification must be kept on site. Atmosphere supplying respirators are used in those atmospheres that lack sufficient oxygen and those environments contaminated with airborne contaminants which are relatively toxic and/or highly concentrated. The use of all respirators requires proper selection, use, inspection, maintenance, training, fit, and other factors. Another type of supplied air respirator is the emergency escape respirator. This type provides clean air to the wearer from a small self-contained cylinder or oxygen-generating chemical and is approved for escape only. Emergency escape respirators cannot be used for entry and have a limited service life from 5 to 15 minutes depending on the model and wearer breathing rate. Respirators are also classified as positive and negative pressure. Positive pressure respirators provide positive pressure within the facepiece during both inhalation and exhalation. Positive pressure within the facepiece minimizes the potential for respirator leakage. Negative pressure respirators draw air into the facepiece via inhalation of the wearer. Any leaks or cracks in the system will allow air contaminants into the facepiece, exposing the wearer. The respirator facepiece assemblies are characterized as quarter mask, half mask, and full face. The full face mask provides the greatest level of protection. An assigned protection factor, or APF, describes the level of protection that a particular type of respirator can be expected to provide 95% of the time. For example, a half-face negative pressure air purifying respirator typically has an APF of 10. Protective body clothing includes fully encapsulating suits, non-encapsulating suits, aprons, leggings, sleeve protectors, heat and firefighters protective clothing, blast and fragmentation suits, cooling garments, radiation protective suits, and more, to include different types of coveralls made of impervious materials to prevent contact with hazardous chemicals and substances. There is a wide range of effective materials to protect against physical, chemical, and biological hazards. Materials such as rubber, plastic films, leather, synthetic fibers, cotton, and more are used for protective garments. These garments are designed to provide protection or a shield against acids, alkalis, temperature extremes, moisture, oils, and more. OSHA and the EPA, in cooperation with other agencies, have established 4 different levels of worker protection that have been standardized for hazardous waste operations. These levels include Level A, Level B, Level C, and Level D. Level A being the highest level of protection and Level D the least. Level A affords the highest level of protection and includes positive pressure full face piece, self-contained breathing apparatus, SCBA, or positive pressure supplied air respirator with escape SCBA. Totally encapsulating chemical protective suit. Inner and outer chemical resistant gloves. Boots, chemical resistant, steel toe and shank. Hard hat, under suit. For all levels of protection, there are options available. Recommended level B protection includes positive pressure full face piece, self-contained breathing apparatus, SCBA, or positive pressure supplied air respirator with escape SCBA, NIOSH approved. Hooded chemical resistant clothing. Inner and outer chemical resistant gloves. Boots, outer chemical resistant steel toe and shank. Hard hat and face shield if appropriate. Recommended level C protection includes full face or half mask air purifying respirators, NIOSH approved. Hooded chemical resistant clothing. Inner and outer chemical resistant gloves. Boots, outer chemical resistant steel toe and shank or disposable boot covers. Hard hat, escape mask, and face shield as appropriate. Level D protection is not much more than a standard work uniform. Recommended level D protection includes coveralls, gloves, chemical resistant steel toe and shank boots, chemical exposure, and as appropriate, safety glasses or chemical splash goggles, hard hat, escape mask, and face shield. Fall protection is intended to prevent death and serious injury from fall hazards. Deaths from falls is ranked second behind motor vehicle accidents with respect to workplace fatalities. Fall protection is designed to prevent falling off of edges, through floors, room openings, off of equipment, and more. Fall protection is required whenever a worker faces serious risk of injury where they could fall more than the OSHA specified height. There are two basic types of personal fall protection systems: fall arrest and travel or fall restraint. Fall protection systems are discussed in more detail in other training courses on fall protection. Fall arrest systems stop a fall within a few feet of the worker's original position and typically requires a full body harness, a lanyard, a rope grab, a lifeline, and a lifeline anchor, all rated at 5,000 pounds breaking strength for most applications. The maximum free fall allowed is 6 feet, or less in some states, such as California, where the limit is 4 feet. A travel or fall restraint system prevents falls by restraining a worker from getting too close to an unprotected edge. Generally, this system consists of a full body harness, a lanyard, a rope grab, a lifeline, and a lifeline anchor, all rated at 5,000 pounds breaking strength for most applications. It is very important to understand that whenever feasible, OSHA requires that instead of having workers rely on fall protection equipment and tying off, temporary floor guardrails, toe boards, or other physical barriers to falls be installed instead. These barriers, such as guardrails, need to meet minimum specifications, such as 42-inch height, spelled out in the standards. High visibility safety apparel can save your life. Like much of the nation's climate, the weather in Colorado, just east of the Rockies, can change quickly. On this particular multiple-acre construction site, activities involved a heavy equipment operation at one location and a field survey crew working on the ground in another location. 3 members of a survey crew working in a relatively remote location was busy setting up their equipment nearing the end of the day. There was no vehicle nor heavy equipment traffic in the area when they were setting up. Reported as the fog cloud that just came out of nowhere, the crew's day turned into night. The whole site quickly became engulfed in a cold, damp fog that lowered visibility to nearly zero. At another location on the site, a heavy equipment operator was involved in scraping and loading activities, saw the fog begin to develop, and as the workday was nearly over for him, he made an attempt to move the equipment to the site equipment yard. In the fog, the operator became disoriented and wandered into the area of the 3-member survey crew. Yet even going slowly in the poor visibility, the conditions were ripe for disaster. The 3-member survey crew, hearing the approaching scraper, could do nothing but attempt to get to their vehicle for cover. At about 15 feet away, seeing nothing but gray-white, the scraper operator identified 3 reddish glows directly in his path of travel and nothing else. The scraper operator immediately stopped the multi-ton vehicle just in time to avert running over and crushing the survey crew. Recently, the American National Standards Institute, ANSI, and the International Safety Equipment Association adopted the American National Standard for High Visibility Safety Apparel in response to concerns that American workers who are exposed to low visibility hazards are not wearing appropriate visibility enhancing apparel. This standard specifies minimum amounts of background fabrics and retroreflective materials for high visibility garments. Background fabrics must be fluorescent yellow-green, fluorescent orange-red, or fluorescent red. The standard establishes 3 classes of high visibility safety clothing. Class 1, 2. High visibility apparel Class 1 has the least amount of fluorescent and retroreflective trim and is designed for workers in occupations such as parking lot attendants, shopping cart retrievers, warehouse workers, roadside or sidewalk maintenance workers, and delivery vehicle drivers. High visibility apparel Class 2 provides superior visibility for wearers and is more conspicuous than Class 1. Garments worn by Class 2 workers are designed for use in occupational activities where risk levels exceed those of Class 1, such as roadway construction and utility repair. Candidates for Class 2 apparel include survey crews, railway workers, school crossing guards, high-volume parking or toll gate personnel, airport baggage handlers and ground crew, emergency response and law enforcement personnel, accident site investigators. Class 3 garments are worn in inclement weather, under heavy traffic conditions, or when complex backgrounds impair visibility. It is intended to provide conspicuity for the user in hazardous situations. Fluorescent lime yellow trim enhances visibility under any light conditions during the day, while reflective trim is brightly visible under illumination by vehicle headlights in low light or dark conditions. OSHA specifies appropriate life-saving equipment, that is, personal flotation devices or PFDs, Be available and warned when employees are working over or near water where the danger of drowning exists. The recent accidental death of a contract worker on a U.S. Army Corps of Engineers dredging project offers fundamental lessons for both commercial and recreational mariners. The worker drowned after falling into the water when a workboat in which he was a passenger was struck by a barge being pushed by a towboat. 3 workers, all wearing personal flotation devices, PFDs, fell from the workboat into the water. 2 made their way back to the dredge. Finding the third person was difficult because of the darkness, but his body was found approximately 30 minutes later, about 200 feet downstream from the dredge. The water temperature of 46 degrees Fahrenheit could have contributed to the death of the drowned victim. Although the victim wore a proper personal flotation device, his PFD did not have a light, making recovery extremely difficult. Another possible contributing factor was lack of proper clothing to insulate against cold water. In summary, these are the lessons learned from this incident. Wear proper personal equipment. Always wear a PFD and make sure it is equipped with a light and sound-making device. A water-activated light and whistle for night operations cost only a few dollars. Employees exposed to drowning. Any personal flotation device, also known as a PFD, shall be approved by the United States Coast Guard as a Type 1 PFD, Type 2 PFD, Type 3 PFD, or their equivalent pursuant to Coast Guard life-saving equipment specifications. Personal flotation devices shall be maintained in good condition. They shall be removed from service when damaged so as to affect their buoyant properties or capability of being fastened, and must be able to support an unconscious person's head above water. Ring buoys shall be U.S. Coast Guard approved, 30 inches in size, equipped with 90 feet of line, placed in readily visible and accessible locations. Distance between ring buoys shall not exceed 200 feet. Some states may have more stringent requirements. For example, in California, ring buoys must have 150 feet of 600-pound test line. Federal OSHA requires that at least one life-saving skiff be immediately available at locations where employees are working over or adjacent to water.
Adjacent to water.
Some states, such as California, elaborate on this requirement and specify that life-saving boats be either manually or power-operated, readily accessible at all times, properly maintained and equipped with oars and oar locks attached to gunnels, boat hook, anchor, ring buoy with 50 feet of 600-pound capacity line, and 2 life preservers. Oars are not required on boats that are powered by an inboard motor. Some states, such as California, allow lifelines to be used in place of life-saving boats if the current is too swift for the use of boats. The line must be stretched across the stream and equipped with tag lines or floating planks at 6-foot intervals. Be advised that you should check your individual state requirements relative to working over or near water. A 3-person geotechnical survey crew was working on a project in which their scope was to map the ocean floor and currents at a location approximately 300 feet offshore, just outside the surf zone, where waves began to rise. They were in a seaworthy, deep beam hole loaded with expensive geotechnical survey equipment. The whole crew were experienced and trained to do this type of work. On the first day of the project, the 3-person crew set out with their equipment in their workboat following established safe work practices and all wearing their U.S. Coast Guard flotation equipment effective for cold water work. As the day progressed, the weather improved. The sun came out and began to warm. It was a beautiful day. At 300 feet offshore, work was going smoothly. The crew, working in gentle rolling water, was completing their work. They decided that the day was so nice that they would remove their cold water personal flotation devices. They believed that absolutely nothing would go wrong. Soon after removing their flotation devices, the gentle rollers increased and a sleeper wave appeared, throwing the crew overboard and capsizing the boat. In the capsizing, one of the crew members was struck on the head by the boat or by the scientific equipment lost overboard. As tens of thousands of dollars of scientific equipment sunk to the ocean floor, the 3 crew members struggled for their lives in frigid cold water, rolling surf and treacherous currents. The crew managed to surface and survey the area for anything that would float and found nothing. The crew member that was struck on the head sustained only a minor injury and was conscious. Miraculously, all 3 members of the crew, being in outstanding physical shape, were able to swim and barely make it to shore, where they summoned help from a passing motorist who was able to call for emergency assistance. All 3 crew members survived to tell the lesson they had learned: to never take water for granted and all. Employer responsibilities. OSHA's primary personal protective equipment standards are in Title 29 of the Code of Federal Regulations, CFR, Part 1910, Subpart I, and equivalent regulations in states with OSHA-approved state plans. But you can find protective equipment requirements elsewhere in the general industry standards. For example, 29 CFR 1926.95 to 106 covers the construction industry. OSHA's general personal protective equipment requirements mandate that employers conduct a hazard assessment of their workplaces to determine what hazards are present that require the use of protective equipment, provide workers with appropriate protective equipment, and require them to use and maintain it in sanitary and reliable conditions. Employers must assess the workplace to determine if hazards are present that require the use of personal protective equipment. If such hazards are present, an employer must select protective equipment. Employers must also train workers who are required to wear personal protective equipment on how to do the following: use protective equipment properly, be aware when personal protective equipment is necessary, know what kind of protective equipment is necessary, understand the limitations of personal protective equipment in protecting workers from injury, put on, adjust, wear, and take off personal protective equipment, and maintain protective equipment properly. Personal protective equipment is a valuable tool in the fight against workplace hazards. PPE is not the first line of defense. Engineering controls such as ventilation, isolation, enclosures are the preferred method. Before acquiring PPE, it is important to do a You have now completed the coursework on this topic. You have now completed the coursework on this topic. OSHA requires you to succeed.
Oh, I should have taken a picture of that one.
Welcome to Health Hazards in Construction. As you may suspect, there are potentially dozens of health hazards on a construction site. You will learn about the most common of these hazards and be given guidance on where to get additional information. This health hazards in construction topic is divided into two subtopics. The first subtopic will give you a general overview of the various health hazards to which construction workers may be exposed, while the second subtopic will be specific to the hazards of respirable crystalline silica. Subtopic 1 should take approximately 2 hours to complete. The second subtopic, when you complete this overview subtopic, you will be able to identify major health hazards common to the construction industry. You will be able to describe what is meant by an acute or chronic health hazard. You will understand how to protect yourself against health hazards. And lastly, you will be able to identify employer requirements for protecting workers from health hazard exposures. Construction work is dynamic, diverse, and constant. Construction workers are at risk of exposure to various health hazards that can result in injury, illness, disability, or even death. Look at the photo. Do you think there might be a potential health hazard here? Use your mouse to identify. This module gives a general overview of the various health hazards to which construction workers may be exposed, including chemical hazards such as dusts, mists, fumes, gases, and vapors. Physical hazards such as heat, noise, and vibration. Biological hazards such as plants, insects, animals, and microorganisms. Ergonomic hazards such as awkward postures in lifting, pushing, and pulling. We will take a look at each of these groups and identify the most. Take a look at the table on your screen. In the first column, you will see several generic construction occupations. In the right-hand column, you'll find the most common potential health hazards. Brick masons are potentially exposed to and experience illness such as cement dermatitis, ergonomic type injury from awkward postures and heavy loads. Drywall installers are potentially exposed to plaster dust, heavy loads, and awkward postures. Electricians are potentially exposed to heavy metals in solder fumes, awkward posture, heavy loads, and asbestos. Painters are frequently exposed to solvent vapors, toxic metals and pigments, and paint additives. Pipe fitters are frequently exposed to lead fumes and particles, welding fumes, and asbestos dust. Carpet layers are frequently exposed to knee trauma, awkward postures, glue, and glue vapor. Additionally, insulation workers can be exposed to asbestos, synthetic fibers, and awkward postures. Roofers to roofing tar and heat. Carpenters to noise, awkward postures, and repetitive motion. Drillers who work in earth and rock drilling are potentially exposed to silica dust, whole body vibration, and noise. Chemical hazards. Chemicals can exist in the form of solids, such as dust, fumes, and fibers, liquids, mists, gases, and vapors. Chemicals are found in a variety of products used at construction sites. Workers may also be exposed to chemicals generated during construction activities. Routes of exposure. Chemicals can enter the body through 1. Inhalation or breathed in. Inhalation is typically the most common way chemicals can enter the body in a work situation. 2. Ingestion or accidental swallowing through eating, drinking, or smoking. 3. Absorption. For example, absorbed through contact. Take a look at the picture on your screen. The photo was taken in a field lab trailer in which the hazardous waste chemist prepared and shipped samples. Can you spot a hazard or hazards? Click on the picture to identify the hazards. There are generally 2 types of health effects from chemical exposure. Acute. Symptoms appear immediately or within a short time following exposure, minutes or hours. Death is possible from some hazardous substances. Acute effects are typically from sudden, short-term, high concentrations. Examples include collapse or death from high levels of carbon monoxide, eye and throat irritation from exposure to ammonia, death and/or serious injury resulting from exposure to hydrogen. Chronic. Symptoms usually develop slowly, as long as 15 to 20 years or more. Exposure may be continued or repeated for a prolonged period, usually years. Examples: lung cancer, asbestosis, mesothelioma from exposure to asbestos, silicosis from exposure to crystalline silica, leukemia from exposure to benzene. Now, let's take a look at some of the common chemical hazards in construction. Asbestos. Construction workers may be exposed to asbestos during demolition or remodeling of older buildings built before 1980, which can contain asbestos insulation or other asbestos-containing products. Asbestos removal can only be done by specially trained asbestos workers. Asbestos exposure can cause breathing problems, lung cancer, and cancer of the lung lining many years after exposure. Welding fumes contain a variety of chemicals depending on what is being welded on, chemical makeup of welding rods, fluxes, and shielding gases. Generally, welding in confined spaces or welding on stainless chromium hexavalent CR6 compounds, often called hexavalent chromium, exist in several forms. Industrial uses of hexavalent chromium compounds include chromate pigments in dyes, paints, inks, and plastics, chromates added as anti-corrosive agents to paints, primers, and other surface coatings, and chromic acid electroplated onto metal parts to provide a decorative or protective coating. Hexavalent chromium can also be formed when performing hot work, such as welding on stainless steel or melting chromium metal. Health effects of hexavalent chromium exposure include lung cancer, asthma, nasal perforation, ulceration, and dermatitis. Millions of workers are exposed to solvents on a daily basis. Health hazards associated with solvent exposure include toxicity to the nervous system, reproductive damage, liver and kidney damage, respiratory impairment, cancer, and dermatitis. Solvents share many chemical, physical, and biological properties that warrant national attention be directed to them as a group. In addition, many solvent groups or individual substances have special properties requiring more specialized control measures. The photo shows a solvent which presents significant health hazards. What do you think might be an excellent source of information to help avoid exposure? Use your mouse on the photo to find out. What is a source of potential hazard in this photo? In addition to environmental issues, what employee hazards are present? Now let's spend a little time on Note that OSHA had. What are the hazards of crystalline silica? Silica exposure remains a serious threat to nearly 2 million U.S. workers, including more than 100,000 workers in high-risk jobs such as abrasive blasting, foundry work, stone cutting, rock drilling, quarry work, and tunneling. The seriousness of the health hazards associated with silica exposure is demonstrated by the fatalities and disabling illnesses that continue to occur in sandblasters and rock drillers. Crystalline silica has been classified as a human lung carcinogen. Additionally, breathing crystalline silica dust can cause silicosis, which in severe cases can be disabling or even fatal. What are the symptoms of silicosis? Silicosis is classified into 3 types: chronic or classic, accelerated, and acute. Chronic classic silicosis, the most common, occurs after 15 to 20 years of moderate to low exposure to respirable crystalline silica. Symptoms may or may not be obvious. Therefore, workers need to have a chest x-ray to determine if there is lung damage. As the disease progresses, the worker may experience shortness of breath upon exercising and have clinical signs of poor oxygen-carbon dioxide exchange. Accelerated silicosis can occur after 5 to 10 years of high exposures to respirable crystalline silica. Symptoms include severe shortness of breath, weakness, and weight loss. The onset of symptoms takes longer than an acute silicosis. Acute silicosis occurs after a few months or as long as 2 years following exposure to extremely high concentrations of respirable crystalline silica. Symptoms of acute silicosis include severe disabling. Are construction workers exposed to crystalline silica? Exposure occurs during many different construction activities. The most severe exposures generally occur during abrasive blasting with sand to remove paint and rust from bridges, tanks, concrete structures, and other surfaces. Other construction activities that may result in severe exposure include jackhammering, rock or well drilling, concrete mixing, concrete drilling, brick and concrete block cutting and sawing, tuck pointing, and tunneling operations. What can employers and employees do to protect against exposures to crystalline silica? Replace crystalline silica materials with safer substitutes whenever possible. Provide engineering or administrative controls where feasible, such as local exhaust ventilation and blasting cabinets. Where necessary to reduce exposures below the PEL, use protective equipment or other protective measures. Use all available work practices to control dust exposures, such as water sprays. Wear disposable or washable work clothes and shower if facilities are available. Vacuum the dust from your clothes or change into clean clothing before leaving the work site. Participate in training, exposure monitoring, and health screening, and surveillance programs to monitor any adverse health effects caused by crystalline silica exposures. Do not eat, drink, smoke, or apply cosmetics in areas where crystalline silica dust is present. Wash your hands and face outside of dusty areas before performing any of these activities.
Ooh.
Now let's talk about lead. Construction workers are and can be exposed to lead during many construction-related activities to include demolition of structures, flame torch cutting, welding, use of heat guns, sanders, scrapers, or grinders to remove and paint, abrasive blasting of steel structures, excavation work in areas with lead contamination, for example, burn pits and landfills. How you can become exposed to lead. Lead is an ingredient in thousands of products widely used throughout industry, including lead-based paints, lead solder, electrical fittings and conduits, tank linings, plumbing fixtures, and many metal alloys. Although many uses of lead have been banned, lead-based paints continue to be used on bridges, railways, ships, and other steel structures because of its rust and corrosion-inhibiting properties. Also, many homes were painted with lead-containing paints. Significant lead exposures can also occur when paint is removed from surfaces previously covered with lead-based paint. OSHA has very strict regulations governing construction worker exposure to lead. Major elements of OSHA's lead standard include a permissible exposure limit, or PEL, of 50 micrograms of lead per cubic meter of air as averaged over an 8-hour period. Requirements that employers use engineering controls and work practices where feasible to reduce worker exposure.
Excuse me.
Requirements that employees observe good personal hygiene practices, such as washing hands before eating and taking a shower before leaving the worksite. Requirements that employees be provided with protective clothing and, where necessary, with respiratory protection. A requirement that employees exposed to high levels of not specific
Break. Oh, okay. Here we go.
Not specifically a chemical hazard, but chemical hazards are often found in them. We are talking about confined spaces. Exposure to chemicals or lack of oxygen in confined spaces can be deadly. Airborne chemicals can quickly reach dangerous levels in confined spaces that are not ventilated. Carbon monoxide, hydrogen sulfide, welding fumes, and solvent vapors are typical confined space chemical hazards. In some confined spaces, oxygen deficiency will cause the person entering to instantly collapse. As many attempted rescuers die in confined spaces as the original world. You come onto a job site and see hazardous substances all the time. On this slide, we will discuss 3 conditions that can pose possible hazards. Click through each of the statements to learn why these conditions must be dealt with. The OSHA Hazard Communication Standard, abbreviated HCS, and sometimes referred to as HAZCOM, has been around for quite some time. The standard is meant to ensure that the hazards of all chemicals produced or imported are classified, and that information concerning the classified hazards is transmitted to employees. HAZCOM provides certain rights to employees. Click on our friend to find out.
Friend.
Employees have both a need and a right to know about the identities and the hazards of the chemicals they are exposed to. They also have a right to know what protective measures are available to prevent adverse effects. Nearly all workers in all industry sectors are covered under OSHA's Hazard Communication Standard. What is the GHS? The GHS is an acronym for the Globally Harmonized System of Classification and Labeling of Chemicals. It is a system for standardizing and harmonizing the classification and labeling of chemicals. It is a logical and comprehensive approach to defining chemical hazards, creating classification processes, and communicating information. The GHS itself is not a regulation or a standard. The GHS document establishes agreed hazard classification and communication provisions and includes information on how to apply the system. This document is referred to as the Purple Book. See the web link to view the OSHA summary. OSHA's HCS aligns with the requirements of the Globally Harmonized System of Classification and Labeling of Chemicals, or GHS, making communication around dangerous chemicals universal. Users and importers of chemicals must follow strict guidelines on how a chemical hazard is classified and labeled, as well as how a chemical is described on safety data sheets. GHS also requires employers to train workers on how to use them. The GHS requires chemicals to be classified into the hazard categories: physical, chemical, or environmental. Once classified, the chemical is given a pictogram to visually represent the chemical's danger. Pictograms appear on labels and safety data sheets. Okay, so now the chemical manufacturer has classified the chemicals by following the GHS criteria. So what? What does that mean to you, and how do you benefit from it? One of the most important aspects of GHS is the use of pictograms to convey the nature of the chemical and its classification. Look at the graphic on your screen. There are 9 pictograms into which all of the physical health and environmental hazards will fall. Spend a few seconds on each pictogram checking the chemical class included, which is shown beneath it. These pictograms will become quite important when we discuss labels a bit later. We have provided this chart in PDF form that you may open and print for future reference. Now let's practice a little so that you can start becoming more comfortable with the pictograms. Click on the pictogram that represents the classification for corrosives. Find the one for oxidizers. Now click on the one for environmental toxicity. Click on the pictogram that represents the classification of irritants. Find the one for the classification of flammables and others. Find the one for the classification of acute toxicity. Locate the one for carcinogens. How about the one for explosives? Finally, click on the pictogram that represents the classification of gases under pressure. Now let's change it up a little. We'll show you the pictogram and you select what it represents from the 3 choices provided for each one. Other GHS label items include a product identifier that should match the product identifier used on the SDS. It should include the chemical name and the chemical identities for all ingredients that contribute to hazards. Supplier identification should include the name, address, and telephone of the manufacturer or supplier of the product. Supplemental information. Although additional information is allowed on a label, supplemental information, it cannot conflict or take away from the required labeling requirements. The labeler has the option of providing supplementary information related to the hazard, such as physical state or route of exposure with a hazard statement. For this label, supplemental information could be: primary route of exposure is ingestion. An example of a label is shown here. Labels where you work may look different so long as they contain all of these required elements: pictogram, signal word, hazard statement, precautionary statement, product identifier, supplier identification, and any supplemental information. Old terminology for many years was MSDS, or Material Safety Data Sheet. Under GHS, the new terminology is Safety Data Sheet, or SDS, and provides comprehensive information for use in workplace chemical management. The document provides information and also advice on safety precautions. The new SDS should contain 16 headings. So what do you do if you find a chemical in your workplace and after reading the label, still aren't sure how you should handle it? Probably your best option is to consult the Safety Data Sheet, or SDS, for the chemical. There should be one available for every chemical you might encounter, and if there isn't, then request one immediately. This is a key component of the Hazard Communication Standard and is not changed by GHS. GHS specifies the format for the SDS, which we'll review in the following screens. Under GHS, the labeling requirements result in valuable key information that must appear on a chemical or its package or container. However, the label does not provide all important and detailed information. The Safety Data Sheet provides detailed information above and beyond the label so that the user can be informed about the many characteristics of the chemical and, most importantly, what must be done to safely use or apply the chemical. Safety Data sheets must follow the 16-section format set by the GHS as shown here. Click on PDF to view a quick card from OSHA describing each of the sections. You may want to print this card to refer to later. Now let's turn our attention to physical health hazards. Physical health hazards are different types of energy which may be hazardous to workers. They include noise, vibration, temperature extremes, ionizing radiation, and non-ionizing radiation. Let's start with noise. Sound is vibrating energy or waves of motion. When these waves strike the ear, they are heard as sound. In general, what we know of as noise is really unwanted sound. Prolonged exposure to excessive noise levels can cause noise-induced hearing loss. Noise levels above 85 decibels can cause hearing loss. When you are exposed to excessive noise levels, the first stage is temporary hearing loss. Over time, the hearing loss becomes permanent. On your screen, you will see various noise levels and pieces of construction equipment or tools and the corresponding noise level that would probably be exceeded. When is noise dangerous? Excessive short-term and long-term exposure to noise can cause hearing loss. Prolonged noise exposure over days, weeks, months, and years above OSHA's action level of 85 decibels, or dBA, averaged over an 8-hour workday may cause hearing loss. Single exposures to very high noise exceeding 115 dBA and higher may cause hearing loss in some individuals. Several factors influence the noise levels to which workers are exposed. Type of equipment being operated, condition or maintenance of the equipment, other equipment running at the same time, enclosed or partially enclosed spaces. High noise levels can be sporadic in construction. Damage to hearing is cumulative and exposure limits are based on 8-hour averages. Workers not using or operating equipment are often exposed to excessive noise as much as the operators. Hearing protection is often used in construction, and they are designed to block out damaging noise from reaching your eardrum. There are two basic types of hearing protection: earmuffs and earplugs. Some earplugs are designed to reduce or attenuate the most harmful frequencies of noise. There are many types of earplugs. Some are pre-molded and some are foam designed to be disposable. One thing is certain: to be effective, earplugs must be inserted correctly. Earplugs are inserted into the ear canal to reduce excessive noise to your middle ear. Always use approved ear protection. Never use cotton, stereo headphones, cigarette butts, or other quick fix methods. Earmuffs generally afford the most protection. Earmuffs are composed of a headband, ear caps, and ear cushions. Earmuffs require a good seal to keep hair, earrings, and glasses from breaking the seal around the ear. For high noise environments such as flight lines, boiler rooms, rattling of bolts, earmuffs in combination with earplugs provide additional protection. In hot weather or tight working conditions, earmuffs can be uncomfortable. Also, since ear protection reduces noise, be especially aware when working around mobile equipment. When is noise dangerous? Vibration can also be a physical health hazard. There are two basic types of work-related vibration: whole body vibration and hand-arm vibration. Whole body vibration, WBV, can occur from operating large mobile equipment such as drillers, air hammers, pile drivers, tractors, graders, excavators, earth-moving equipment, and other large machinery. Whole body vibration is transmitted through the seat or feet of employees who drive mobile machines or other work vehicles, especially over rough and uneven surfaces. Hard shocks and jolts may cause health risks, including back pain. Some tips to prevent or minimize exposure to whole body vibration include introducing working methods which eliminate or reduce exposure. For example, minimizing the transport of goods and materials, or to replace manned with unmanned machines such as remotely controlled conveyors. Choosing work equipment to appropriate ergonomic design. Considering the choice of seat, including suspension seats, and the choice of tires. Regular maintenance of vehicles, including their seats and suspension, and maintenance of unmade roads and ground conditions throughout sites to suit the machines that use them, will greatly reduce shocks and jolts.
Yeah.
Limiting the duration and magnitude of exposure. Ensuring the work schedules have
What's
adequate
up?
rest
Yeah,
periods.
the boys ready. Can you help me?
Yes.
Shouldn't take too long. I need to change my shoes.
Okay. I'll be there in just a second. Alright, I'll be back. Back. Oh, okay.
Which of the following are
Some
forms
tips
of
to
heat
prevent
illness?
or minimize exposure to whole body vibration include introducing working methods which eliminate or reduce exposure. For example, minimizing the transport of goods or materials, or to replace manned with unmanned machines such as remotely controlled conveyors. Choosing work equipment to appropriate ergonomic design. Considering the choice of seat, including suspension seats, and the choice of tires. Regular maintenance of vehicles, including their seats and suspension, and maintenance of unmade roads and ground conditions throughout sites to suit the machines that use them, will greatly reduce hand-arm vibration, or HAV, can result from using handheld power tools such as pneumatic drills and hammers and disc grinders. Hand-arm vibration may cause carpal tunnel syndrome, a disease that affects the fingers and hands. In the long run, permanent damages to the nerves will result in a loss of the sense of touch and dexterity. Working in a cold and damp environment can aggravate the harmful effects of hand-arm vibration. Risk controls include alternative work methods. Look for alternative work methods which eliminate or reduce exposure to vibration. Mechanize or automate the work. Make sure that equipment selected or allocated for tasks is suitable and can do the work efficiently. Equipment that is unsuitable, too small, or not powerful enough is likely to take much longer to complete the task and expose employees to vibration for longer than is necessary. Select the lowest vibration tool that is suitable and can do the work efficiently. Limit the use of high vibration tools wherever possible. Introduce appropriate maintenance programs for your equipment. Limit the time exposed to vibration. Wear protective clothing when necessary to keep hands warm and dry. This will encourage good blood circulation, which should help protect them from developing vibration white finger. A change in body temperature due to extreme work environmental conditions can lead to stress or illness from heat or cold. If not treated in time, both heat and cold stress or illness can develop into life-threatening situations. Heavy work at high temperatures can cause muscle cramps, dehydration, sudden collapse, and unconsciousness. Cold temperatures can lead to fatigue, irregular breathing, confusion, and loss of consciousness, hypothermia. Hot conditions can occur from prolonged work under direct sunlight in summer, for example, asphalt paving or roofing. Wearing impermeable protective clothing when doing heavy work. Working in an enclosed area with a strong heat source. For ventilation in high humidity. For example, heavy equipment operators in an enclosed pad without sufficient ventilation. What are 4 different types of energy which may be hazardous to workers? Heat illnesses can include any of the following: heat rash, fainting, heat cramps, heat exhaustion, and heat stroke. Symptoms of heat illness. Early symptoms include fatigue, heavy sweating, headache, cramps, dizziness, high pulse rate, nausea, or vomiting. Life-threatening symptoms include high body temperature, red, hot, dry skin, confusion, convulsions, fainting. Prevent heat illness. There are some steps you can take to help prevent heat illness. Tell your supervisor if you are new to working in the heat or have had heat illness before. Stay alert to the weather. During a heat wave, you are at greater risk of getting sick. You need to watch yourself and co-workers more closely and may need to drink more water, take more breaks, and use other measures. Drink enough cool, fresh water. Drink at least one 8-ounce cup cones every 15 minutes during your entire work shift. Do not wait until you are thirsty to drink water. Do not drink alcohol. Avoid coffee. Choose water over soft drinks. Take rest breaks in the shade to cool down. Wear proper clothing. Loose-fitting, lightweight, and light-colored cotton clothes, a wide-brimmed hat or cap, and a bandana if appropriate. Talk to your doctor if you have illnesses like diabetes, are taking medicines, or are on a low-salt diet. Which of the following are forms of heat illness? What about cold stress? Cold conditions can result from cold air temperatures, rain, snow, sleet, or other wet weather conditions, windy conditions, underground construction work, working over water and falling in. Cold illnesses and injuries include immersion injury, trench foot. Immersion injury is a peripheral, non-freezing cold injury resulting from exposure to water, usually at temperatures just above freezing. Frostnip, which is the initial stages of frostbite and affects generally just the surface of the skin. Frostbite affects skin and other tissues due to extreme cold. Frostbite is most likely to happen in body parts farthest from the heart and those with large exposed areas. Hypothermia. Hypothermia is abnormally low body temperature. Body temperature that is too low affects the brain, making the victim unable to think clearly or move well. This makes hypothermia particularly dangerous because a person may not know it is happening and won't be able to do anything about it. Workers should avoid exposure to extremely cold temperatures when possible. When cold environments or temperatures cannot be avoided, workers should consider following these recommendations to protect themselves from cold stress. Wear appropriate clothing. Wear several layers of loose clothing. Layering provides better insulation. Tight clothing reduces blood circulation. Warm blood needs to be circulated to the extremities. When choosing clothing, be aware that some clothing may restrict movement, resulting in a hazardous situation. Make sure to protect your ears, face, hands, and feet in extremely cold weather. Boots should be waterproof and insulated. Wear a hat that will keep your whole body warmer. Hats reduce the amount of body heat that escapes from your head. Move into warm locations during work breaks. Limit the amount of time outside on extremely cold days. Carry cold weather gear such as extra socks, gloves, hats, jacket, blankets, a change of clothes, and a thermos of hot liquid. Include a thermometer and chemical hot packs in your first aid kit. Avoid touching cold metal surfaces with bare skin. Monitor your physical condition, that of your coworkers. Radiation. Radiation may be defined as energy traveling through space. Ionizing radiation is essential to life, but excessive exposures will cause tissue damage. All forms of ionizing radiation have sufficient energy to ionize atoms that may destabilize molecules within cells and lead to tissue damage. Radiation sources are found in a wide range of occupational settings. If radiation is not properly controlled, it can be potentially hazardous to the health of workers. Ionizing radiation sources may be found in a wide range of occupational settings to include construction, healthcare facilities, research institutions, nuclear reactors and their support facilities, nuclear weapon production facilities, and other various settings, just to name a few. These radiation sources can pose a considerable health risk to affected workers if not properly controlled. Examples are X-rays and gamma rays from equipment used to gauge the density and thickness of pipes, to inspect welds, or for detecting weakness of structures and radioactive isotopes for flow meters. Click on the link to OSHA's Ionizing Radiation Safety and Health Topics page to learn of Radiation affects people by depositing energy in body tissue, which can cause cell damage or cell death. In some cases, there may be no noticeable effect. In other cases, the cell may survive but become abnormal, either temporarily or permanently. Additionally, an abnormal cell may become malignant. Both large and small doses of radiation can cause cellular damage. The extent of the damage depends upon the total amount of energy absorbed, the time period and dose rate of the exposure, and the particular organs exposed. Three basic concepts apply to protecting yourself from all types of ionizing radiation: time, distance, and shielding. Time. The amount of radiation exposure increases as the time spent near the source of radiation increases. Distance. The farther away people are from a radiation source, the less their exposure. Shielding. The greater the thickness and density of shielding around a radiation source, the smaller the exposure. If you have the potential for exposure to radiation, it is important that you get training and information from your employer. Non-ionizing radiation is described as a series of energy waves composed of oscillating electric and magnetic fields traveling at the speed of light. Non-ionizing radiation includes the spectrum of ultraviolet or UV, visible light, infrared, IR, microwave or MW, radio frequency, RF, and extremely low frequency, ELF. Lasers commonly operate in the UV, visible, and IR frequencies. Non-ionizing radiation is found in a wide range of occupational settings and can pose a considerable health risk to potentially exposed workers if not properly controlled. The principal health effects of non-ionizing radiation include the following: skin cancer, eye damage, premature skin aging, burns. The best protection to non-ionizing radiation is to avoid exposure when able. Protective equipment should be worn when potentially exposed and dependent upon the type of non-ionizing sources. For example, cover up, wear a hat, and use sunscreen when exposed to intense sunlight, or wear special protective eyewear when potentially exposed to laser. What are the three basic ways to protect yourself from all Biological agents include bacteria, viruses, fungi, other microorganisms, and their associated toxins. They have the ability to adversely affect human health in a variety of ways, ranging from relatively mild allergic reactions to serious medical conditions, even death. These organisms are widespread in the natural environment. They are found in water, soil, plants and animals. Because many microbes reproduce rapidly and require minimal resources for survival, they are a potential danger in a wide variety of occupational settings. Diseases or illnesses can occur from biological sources, which include West Nile virus, Lyme disease, histoplasmosis, a fungus in bird droppings, hantavirus. Learn more about exposure to biological agents may occur during demolition, renovation, sewer work, earthwork, work on air handling systems, or other construction work from contact with contaminated or disease-carrying soil, water, insects such as mosquitoes or ticks. Bloodborne pathogens are infectious microorganisms in human blood that can cause disease in humans. These pathogens include, but are not limited to, hepatitis B, HBV, hepatitis C, HCV, and human immunodeficiency virus, HIV. Needle sticks and other sharps-related injuries may expose workers to bloodborne pathogens. Workers in many occupations, including first aid team members, housekeeping personnel in some industries, medical waste cleanup workers, nurses, and other healthcare personnel may be at risk of exposure to bloodborne pathogens. In order to reduce or eliminate the hazards of occupational exposure to bloodborne pathogens in those jobs where exposure to blood or other potentially infectious materials are anticipated, an employer must implement an exposure control plan for the work site with details on employee protection measures. The plan must also describe how an employer will use a combination of engineering and work practice controls, such as universal precautions, ensure the use of personal protective clothing and equipment, provide training, medical surveillance, hepatitis B vaccinations, and signs and labels, among other provisions. Poisonous plants found in the United States include poison ivy, poison oak, and poison sumac. These plants can cause allergic reactions if the leaves or stalks are damaged and come in contact with workers' skin. Some construction workers may be exposed to many types of venomous wildlife and insects. Venomous snakes, spiders, scorpions, and stinging insects can be found throughout various geographic regions of the U.S. They are especially dangerous to workers who have allergies to the animal. Anaphylactic shock is the body's severe allergic reaction to a bite or sting and requires immediate emergency care. Thousands of people are stung each year, and as many as 40 to 50 people in the United States die each year from severe allergic reactions. It is important for workers to be familiar with the potential biological hazards associated with their activities and follow established, safe work practices. Bloodborne pathogens are infectious microorganisms in human blood that can cause disease in humans. Which of these are considered to be bloodborne pathogens? Ergonomic hazards can cause painful and disabling injuries to joints and muscles. They can occur from heavy, frequent, or awkward lifting, repetitive tasks, awkward grips or postures, using excessive force, overexertion, using the wrong tools for the job, or using tools improperly, using improperly maintained tools, and hand-intensive work. Ergonomic hazards can lead to musculoskeletal disorders, MSDs, and injuries, strains and sprains, one of the most common injuries among construction workers, tendinitis, carpal tunnel syndrome, low back pain, and fatigue. Did you know the number of back injuries in U.S. construction was 50% higher than the average for all other U.S. industries Backaches and pain in the shoulders, neck, arms, and hands were the most common symptoms reported by construction workers in one study. Material handling incidents account for 32% of workers' compensation claims in construction and 25% of the cost of all claims. The average cost per claim is $9,240. Musculoskeletal injuries can cause In this module, we have discussed multiple health hazards, many of which can be found on the construction site. These have included chemical hazards, physical hazards, biological hazards, and ergonomic hazards. It is important in this module we have discussed multiple health hazards, many to several health hazards at the same time or on the same work site over time. For example, this worker is simultaneously exposed to noise, silica dust, vibration, and ergonomic hazards. We have shared with you many tips and links to safety and health information along the way. On this screen, you will find a few more to include OSHA, NIOSH, and more. It is important that you do your part to be aware of health hazards and to take steps to recognize, evaluate, and control your exposures when able. If you recognize a hazard, report it and follow established safe work practices. We've discussed some employer responsibilities. Let's go over those here. Employers must identify and list chemicals in the workplace. Obtain MSDSs and labels for each chemical, and develop and implement written programs that include chemical lists, labels, MSDSs, personal protective equipment or PPE, and employee training. Employee training plans must include general and site-specific information, how the HAZCOM program is implemented, hazards of the chemicals in the area, measures employees can take to protect themselves, location and use of PPE if required, and methods and observations workers can use to detect the presence of a chemical. Employers must also train employees in the recognition and control of physical health hazards, biological hazards, and ergonomic hazards, and provide engineering, work practice controls, and PPE to eliminate or mitigate the hazards. This second subtopic in health hazards in construction is designed to teach the essential elements of OSHA's respirable crystalline silica standard, found in 29 CFR 1926.1153. Construction workers and employees may routinely work near or otherwise be exposed to silica or respirable crystalline dust, requiring them to be trained above the simple awareness introductory level. Supervisors and managers who oversee employees with routine exposure may also be exposed. Thus, this subtopic is applicable to employers and employees, as well as supervisors and managers who are in construction or perform construction-related activities, including environmental remediation contractors. The duration. In the next hour, you will learn the basics of silica dust and respirable crystalline silica dust. This topic will help you to identify the health hazards of respirable crystalline silica associated with performing many common construction tasks, along with some specific control measures that employers must implement to protect those they employ. Control measures include engineering controls, special work practices, and the use of a respirator. You will also learn about housekeeping as it relates to silica dust. By the end of this subtopic, you'll be able to explain what respirable crystalline silica is, along with its associated health hazards. Identify construction activities and equipment commonly linked to respirable crystalline silica. List the control measures and respiratory protection required under OSHA's standard on respirable crystalline silica, and recognize employer responsibilities and employee rights under OSHA standard on respirable crystalline silica. OSHA's respirable crystalline silica standard is found in 29 CFR 1926.1153. This standard applies to all occupational exposures to respirable crystalline silica in construction work, except where employee exposure will remain below 25 micrograms per cubic meter of air as an 8-hour time-weighted average, or TWA, under any foreseeable conditions. Click Tip to learn more about air monitoring. Also, click View PDF if you would like to see the respirable crystalline silica standard. The key provisions of OSHA's construction standard for respirable crystalline silica are as follows. It reduces the permissible exposure limit, or PEL, for respirable crystalline silica to 25 micrograms per cubic meter of air averaged over an 8-hour shift. It requires employers to use engineering controls, such as water or ventilation, to limit worker exposure to the PEL. Provide respirators when engineering controls cannot adequately limit exposure. Limit worker access to high exposure areas. Develop a written exposure control plan. Offer medical exams to highly exposed workers and give them information about their lung health, and train workers on respirable crystalline silica risks and how to limit exposures. It provides flexibility to help employers, especially small businesses, protect workers from respirable crystalline silica exposure. Click Tip for an explanation about permission. Crystalline silica is a basic component of soil, sand, granite, and many other minerals. Quartz is the most common form of crystalline silica. Cristobalite and tritonite are two other forms of crystalline silica. Click Tip to learn about materials that contain quartz. Respirable crystalline silica means quartz, cristobalite, and or tritonite contained in airborne particles that are determined to be respirable by a sampling device designed to meet the characteristics for respirable particle size selective samplers specified in the International Organization for Standardization, or ISO, air quality.
particle size fraction definitions for health-related sampling. All three forms may become respirable size particles when workers chip, cut, drill, or grind objects that contain crystalline silica. Click tip to learn more about the meaning of the term respirable. Which of the following is the most common form of crystalline silica? Click on the correct answer. The U.S. Department of Labor first highlighted the hazards of respirable crystalline silica in the 1930s after a wave of worker deaths. The department set standards to limit worker exposure in 1971 when OSHA was created. However, the standards are outdated and do not adequately protect workers from silica-related diseases. Furthermore, workers are being exposed to respirable crystalline silica in new industries such as stone or artificial stone countertop fabrication and hydraulic fracturing. A full review of scientific evidence, industry consensus standards, and extensive stakeholder input provide the basis for the final rule, which was proposed in September 2013. The rulemaking process allowed OSHA to solicit input in various forms for nearly a full year. The agency held 14 days of public hearings, during which more than 200 stakeholders presented testimony and accepted over 2,000 comments, amounting to about 34,000 pages of material. In response to this extensive public engagement, OSHA made substantial changes, including enhanced employer flexibility in choosing how to reduce levels of respirable crystalline silica while maintaining or improving worker protection. The Occupational Safety and Health Administration, or OSHA, has issued a final rule to curb lung cancer, silicosis, chronic obstructive pulmonary disease, and kidney disease in America's workers by limiting their exposure to respirable crystalline silica. The rule is comprised of two standards, one for construction and one for general industry and maritime. In addition to respirable crystalline silica being classified as a human lung carcinogen, that is, a cause of lung cancer, it can also cause silicosis. In a case of silicosis, the respirable silica dust enters the lungs and causes the formation of scar tissue, thus reducing the lung's ability to take in oxygen. In severe cases, silicosis can be disabling or even fatal. There is no cure for silicosis. Since silicosis affects lung function, it makes one more susceptible to lung infections like tuberculosis. In addition, smoking causes lung damage and adds to the damage caused by breathing silica dust. Silicosis is classified into three types: chronic or classic, accelerated, and acute. Click on the buttons to learn about each type. Chronic, acute silicosis. Select the correct answer under each of the three types of silicosis. About 2.3 million workers are exposed to respirable crystalline silica in their workplaces, including 2 million construction workers who drill, cut, crush, or grind silica-containing materials, such as concrete and stone, and 300,000 workers in general industry operations such as brick manufacturing, foundries, and hydraulic fracturing, also known as fracking. Responsible employers have been protecting workers from harmful exposure to respirable crystalline silica for years using widely available equipment that controls dust with water. OSHA estimates that the respirable crystalline silica rule will save over 600 lives and prevent more than 900 new cases of silicosis each year once its effects are fully realized. The final rule is projected to provide net benefits of about $7.7 billion annually. Before we discuss the various types of control methods used to reduce or avoid exposure to respirable crystalline silica, we first need to understand the importance of hazard identification and evaluation. Hazard identification is a key part of the respirable crystalline silica hazard control process. If hazards aren't identified, then they can't be mitigated or controlled properly. It is important to collect and review information such as safety data sheets, equipment manuals, and inspection reports. It is important to inspect and observe activities at the job site that may be the source of respirable crystalline silica hazards, such as those that have the opportunity to produce dust. It is important to involve workers by talking to and listening to their feedback to effectively find hazards. It is important to investigate incidents of potential exposures and important to stay tuned into information concerning silica and related hazards available from OSHA, the National Institute for Occupational Safety and Health, NIOSH, insurance carriers, safety and industrial hygiene associations, and similar organizations. Hazard evaluation, or worksite analysis, is an essential step that helps an employer determine what jobs and workstations are the sources of potential problems. Worksite analysis to determine respirable crystalline silica exposure is generally conducted by a qualified industrial hygienist or safety professional. We will refer to them as the qualified person. During the worksite analysis, the qualified person measures and identifies exposures, problem tasks, and risks. The most effective worksite analyses include all jobs, operations, and work activities with potential risk. The qualified person inspects, researches, or analyzes how the particular chemicals or physical hazards at that worksite affect worker health. If a situation that is hazardous to health is discovered, the industrial hygienist recommends the appropriate corrective actions. This step often includes air monitoring and measurement, which most often requires the assistance of employees by wearing air sampling pumps and similar equipment. If our hazard identification and hazard evaluation, or worksite analysis, identifies a real or potential respirable crystalline silica hazard, selecting the best method or combination of methods of hazard control will depend upon the specific work task and projected level of exposure. Available options may include dust suppression, such as wet methods, surfactants, and other soil binding materials, vacuum dust collection, or VDC, respiratory protection, ventilation booths, and operator isolation. Fans often may provide additional protection. Wet dust suppression techniques use water sprays to wet the material so that it generates less dust. Often, wet methods, that is, methods involving the application of water, are the easiest and most effective way to reduce potential silica exposures, as dust that is wet is heavier and less able to become or remain airborne. Water can be applied in different ways to suit the specific situation. Depending on the size and type of the job, construction employees can use a variety of equipment, from a portable garden sprayer to a fire hose. Freezing temperatures can complicate the use of water. Heating the local work area, if possible, is a good way to prevent ice from forming in the water feed system. Large portable heating units are commonly used to heat commercial and sometimes road and highway projects. Always drain water feed systems when they are not in use. If water freezes on the ground, it can present a slipping hazard. Be sure to chip away ice or use de-icing compounds or sand. While electrical safety is always a concern during work with and around electrical tools and equipment, it is particularly important when conducting tasks in wet or damp areas. When using water to control dust, be sure to use watertight, sealable electrical connectors for electric tools and equipment. It is best to employ ground fault circuit interrupters, or GFCIs, although an assured equipment grounding conductor program can be an acceptable alternative. OSHA continues to emphasize that GFCIs afford better protection and should be used whenever possible. Which of the following is typically true of wet methods for controlling exposure to respirable crystalline silica? Click on the best answer. A dust collection system which pulls dust away from the source is another effective way to reduce dust emissions. A typical vacuum dust collection or VDC system, which may be purchased as a kit, consists of a dust collector as an exterior hood, a vacuum hose, and a filter or filters. Each of these components plays a vital role in the operation. Always ensure that the entire system is clean and free of leaks or cracks. Click Tip to learn more about choosing a vacuum. Poor performance of any one component of a vacuum dust collection system, or VDC, can reduce the effectiveness of others. Careful selection of each component and routine maintenance and inspection is critical. Ensure the dust collector and vacuum are the appropriate size and have the right power capacity. Choose a vacuum hose that will permit the proper airflow rate and use high-efficiency particulate air filters, also known as HEPA filters, for maximum dust control. Click Tip to learn more. If at any point the use of various control measures does not sufficiently limit the silica exposure below the OSHA PEL, respiratory protection is required. The level of respiratory protection afforded by various systems relies in part on factors in the work environment, such as enclosed versus open spaces, the number of operations generating silica dust, environmental conditions such as wind direction and speed, and the percentage of silica found in materials. Click Tip to learn about employees who might not be doing the work but are working near the operations where silica dust is being produced. In the case where respirators become necessary or are required by the employer must establish and implement a written respiratory protection program. This program must cover worksite specific procedures and elements, including proper selection, usage, maintenance, and care of respirators, as well as medical evaluations, fit testing, and training for employees. Table 1 of the Silica Standard prescribes two forms of minimum required respirators, APF 10 and APF 25. APF stands for Assigned Protection Factor. The APF level indicates the workplace level of respiratory protection that a respirator or class of respirators is expected to provide to employees when the employer implements a continuing effective respiratory protection program. Click the buttons to reveal images of APF 10 and APF 25 respirators, as well as a chart that explains assigned protection factors. Fit testing is done to be sure that the respirator
will be pulled into the facepiece and can be the quick check performed by the
facepiece
wearer
fits the
each
face.
time the respirator is put
Click on
on.
the image that shows
It
examples
determines
of
if the
APF
respirator
10
is proper.
respirators. Fans are not effective dust control devices in and of themselves and should never be used as the primary method for managing dust. However, with that in mind, fans can be a helpful supplement if used in partnership with other dust.
Which is the volume may be recommended to reduce dust. All of them go.
Table 1 of Let's start with the first piece of equipment mentioned in Table 1, stationary masonry saws. To protect yourself from respirable crystalline silica while using this kind of tool, use a saw equipped with an integrated water delivery system that continuously feeds water to the blade. And as mentioned earlier, don't forget to follow the manufacturer's instructions on how to use your work equipment so that you keep silica dust exposure to a minimum. To see the OSHA publication on controlling silica exposures in construction while operating stationary masonry saws, click View PDF. For handheld power saws of any blade diameter, again, use a saw equipped with an integrated water delivery system that continuously feeds water to the blade. Click Respirator Required to reveal the type of respirator required when this tool is used outdoors or indoors. Additionally, click View PDF if you would like to read the OSHA publication on controlling silica exposures in construction while operating handheld masonry saws. With handheld power saws for cutting fiber cement board, and here we are talking about saws with a blade diameter of 8 inches or less, used for tasks performed outdoors only, use a saw equipped with a commercially available dust collection system. The dust collector must provide the airflow recommended by the tool manufacturer or greater, and have a filter with 99% or greater efficiency. Just as when it comes to using drivable saws for tasks performed outdoors only, use a saw equipped with an integrated water delivery system that continuously feeds water to the blade. Click Tip, important reminder. Which of the following activities uses a wet method as a control? Click all the correct answers. For rig-mounted core saws or drills, Table 1 again describes a wet control method. Use a tool equipped with an integrated water delivery system that supplies water to the cutting surface. Now let's discuss handheld and stand-mounted drills, which include impact and rotary hammer drills. Use a drill equipped with a commercially available shroud or cowling with a dust collection system. The dust collector must provide the airflow recommended by the tool manufacturer or greater, and have a filter with 99% or greater efficiency, and also have a filter cleaning mechanism. Be sure to use a HEPA filtered vacuum when cleaning holes. Now let's discuss the controls for vehicle-mounted drilling rigs for rock and concrete. Use a dust collection system with a close capture hood or shroud around the drill bit with a low-flow water spray to collect the dust at the discharge point from the dust collector. Or as an alternative method, operate the vehicle-mounted drill rig from within an enclosed cab and use water for dust suppression on the drill bit. Click View PDF if you would like to read OSHA's publication on for jackhammers and handheld powered chipping tools. Use a tool with a water delivery system that supplies a continuous stream or spray of water at the point of impact. Another control method when using jackhammers and handheld powered chipping tools is to use a tool equipped with a commercially available shroud and dust collection system. As mentioned earlier, when we discussed using a dust collector, it must provide the airflow recommended by the tool manufacturer or greater, and have a filter with 99% or greater efficiency and a filter cleaning mechanism. Click Respirator Required to reveal the type of respirator required when this tool is used outdoors or indoors. Which of the following activities uses a wet method as a control? Click all the correct answers.
Let's continue our study of common construction activities and equipment that produce silica dust. For handheld grinders for mortar removal, such as during tuck pointing, when old mortar is removed from between bricks for repair, you would use a grinder equipped with commercially available shroud and dust collection system. The dust collector must provide 25 cubic feet per minute, or CFM or greater, of airflow per inch of wheel diameter and have a filter with 99% or greater efficiency, and it must have a cyclonic pre-separator or filter cleaning mechanism. And let's not forget to operate and maintain any of these silica dust producing tools in accordance with the manufacturer's instructions to minimize dust emissions. Click Respirator Required to reveal the type of respirator required when this tool is used. Because of the exposure hazards to respirable crystalline silica while operating this equipment, please note that OSHA requires the use of an APF 25 respirator when using the tool for over 4 hours in a shift. Also click View PDF if you would like to read OSHA's publications on controlling silica exposures in construction while operating hand-operated grinders, and controlling silica exposures in construction while doing tuck pointing with handheld grinders for with handheld grinders for uses other than mortar removal when these tasks are the employer must ensure that each user grinder is covered by the integrated water delivery system that continuously feeds water to the grinding surface. As another control method, when using a handheld grinder for activities other than mortar removal and tuck pointing, you can use a grinder equipped with a commercially available shroud and dust collection system. The dust collector has the same required specification as for the dust collector used in mortar removal. Provide 25 cubic feet per minute, or CFM or greater, of airflow per inch of wheel diameter, and have a filter with 99% or greater efficiency and a cyclonic pre-separator or filter cleaning mechanism. Click Respirator Required to reveal the type of respirator required when this tool is used indoors. The following items are the list of activities that require respirators per Table 1 of the Respirable Crystalline Silica Standard. Click on the one activity that requires an APF 25 respirator for more than 4 hours of at-risk activity in a shift. When using walk-behind milling machines and floor grinders, use a machine equipped with an integrated water delivery system that continuously feeds water to the cutting surface. There is an alternative control method to protect yourself from silica dust exposure when using a walk-behind milling machine and floor grinder. This method is to use a machine equipped with a dust collection system recommended by the manufacturer. The dust collector must provide the airflow recommended by the manufacturer or greater and have a filter with 99% or greater efficiency and a filter cleaning mechanism. When used indoors or in an enclosed area, use a HEPA filtered vacuum to remove loose dust in between passes. For small, drivable milling machines that are less than half lane wide, use a machine equipped with supplemental water sprays designed to suppress dust. Remember, water must be combined with a surfactant.
Get rid of that one.
Quick tip, if you would like to learn what a surfactant is.
Which of the following? Where do I work? Just construction. Where's all the chat? What's up? There, stay. I wish the chat would stay there for just a minute. Jeez Louise.
When you are operating
if I
a
hit
large
the- oh.
drivable milling machine that is
Hit
half
this.